Right. We should be live, hopefully.
Hello.
Let's find out. Um, Hopefully, people can see and hear us.
Testing. Yeah.
Um, so, game plan today. We're to be honest, we're gonna be winging our experience a little bit. We're trying to do the framework for the design of a robotic arm. So today I'll be start with some research, demoing our software where it stands. We're going to be trying to use the software to build some initial single line diagrams and maybe some very basic 3D models for what we're trying to develop. Today will be just electrical most likely, but stream number two will probably dive into some 3D modeling and go down that avenue to actually build an arm and build the grabber for the arm. Um, Through Glavin's research, he sort of came up with the conclusion that the easiest way to do this, or at least the recommended way to do this, would be to do from the grabber down to the base.
Hopefully that works out. Yeah.
Hopefully that works. We'll take the recommendation. We'll run with it. Worst case, we make more problems that we have to solve along the way.
And you can learn with us. So it'll be great. Win-win.
We'll have to. It's going to be interesting. We're going to be touching on some at some point, probably not today, but at some point we'll be talking about different grip strengths, required grip strengths to hold certain materials, and we're going to be talking about the effects of moment forces, which would be like extension forces, and it's going to be a lot of civil-esque engineering, which, to be honest, I'm not the most competent in. So it'll be a fun adventure.
That's going to be great. We're going to learn together on this one.
Yeah, this is.
Yeah, if anyone has any ideas in the chat, also let us know. We'll be very interactive.
And certainly while you're in the chat, if you have any ideas on sort of the layout of the software as it stands, it'd be very helpful. We're still trying to figure out how to make it more user friendly. As it stands, it's sort of what I would consider an engineering piece of software, as in it has a bit of a learning curve to get to be proficient in it. But nonetheless, it has a lot of functionality.
That's the hope.
Yeah. Yeah, we're still a long way away from having a commercially viable product, but nonetheless, it's definitely come a long way in the last 6 months or so since the last time anybody would have seen this app. Yeah, so we're just sending some messages, get some people, see if anybody wants to join us for the watch, and
hang around,
and then we're gonna dive into some research type things. You should pull that onto your live screen.
Yeah, so I can show you what we have in mind for today. For some of you who may have watched us in the past, this is something I think a year ago we actually made for our remote control car. And this was, I can't remember what software it was, maybe it was Lucidchart, but we were pulling in different components and wiring them up. And this is definitely something we wanted to address, is how do we make this experience easier? So we're hoping that the software we're going to demonstrate to you today is what we built and is going to tackle this problem, and something that we'll continue to use and refine. And then if anyone else wants to build similar projects, now you'll have a tool to make that easy and user-friendly for you. Yeah, so we're going to show it off.
Yeah, I guess I do want to give one more little piece of info on that. The idea is to kind of have an all-inclusive piece of software for some simplistic engineering designs, at least simplistic out of the gate. And as we sort of move further and add more functionality, the projects could become more and more advanced as we sort of dive into new components and new pieces of software. As it stands right now, I would suggest it's not necessarily all inclusive. We don't necessarily have the ability to actually develop software for our design, so it'll be mostly hardware related. But that'll come soon, and hopefully it'll be a world where you can do complete design and simulation of your products before you bring them to life in the real world.
Yeah, and teach other people what you're building too. Have some integrated course features, so you can have a really cool project like our car that we built, and then help others, guide them through to how to build it, from the system diagram you see in front of us to more of the hardware pieces and where they're going to be placed physically, to writing the software to make sure it actually can run and not colliding walls in the case of our RFT car. So. Yeah, a lot of cool stuff.
Perhaps maybe it'd be a good place to start if you wanted to pull up. I know the light course isn't necessarily up to date, but you do have the option to look at the light course.
Let me see if I can get that up for us.
Just to kind of show you at least the direction we're going with this.
I have the old one, not the the unpublished one, or.
Yeah, I was thinking if we could just to show, maybe we could do like a side by side of like what we did originally, which would be what you're
Oh
pulling up
man,
now.
he's put me to the tests.
Yeah.
Okay. Yeah. Keep talking for a little bit. I'll see what I can pull up.
Yeah, so while Glavin's kind of trying to pull up our existing IntelliToys webpage as well as the side by side with the new design, I'll give you a rundown of what we're trying to accomplish at the very least. We did a bit of I wouldn't say it's a full 180 on the design, but originally the idea was to have a place where you could build courses very effectively and hopefully in good competition with things like online learning courses where you have to make videos and there's no real it's very challenging to sort of update online videos because you obviously have to make a new video, whereas we have an interactive solution that when you're updating your course, you can basically just make minor adjustments on the fly. But now we've sort of flipped that a little bit, and we're aiming a little bit closer to we want the design a platform for complete design that you can also make courses in. So it'd be you design a project like an arm, like we're about to try to accomplish, and as you're going, you're writing an instruction list, and it will allow you to produce 3D models and 2D diagrams showing how to go through the design process. And like I said before, hopefully get to a point where we can actually do the coding and simulation within that as well. So you can for example, drive a car around in a 3D environment, or move an arm in a 3D environment, and maybe even put in some machine learning based on some physical constraints within the 3D environment. For example, a ball comes across the screen and the arm could try and catch the ball. That seems pretty extreme, and I think Glavin's probably going to push back on that one. But just an idea, just a hypothesis, let's say.
Wait, I missed that. Since when have I ever pushed back on anything? I'm the king of feature creep.
We were talking the other day about this new technology that's sort of rearing its head over the last few years. It's called microbial fuel cells.
Oh yeah.
And we started talking. Basically, a microbial fuel cell is the idea of using what's called electrogens, which is a bacteria that's found near plant roots, because it does the same thing as plants. It takes sugars, it takes carbohydrates and water, and basically does an anaerobic reaction, which actually results in the release of an electron. So when that happens, there's ways to capture that by having an anode or a piece of metal in the ground around those bacteria, and you can quite honestly capture electricity. So I was sort of proposing that we do some experimenting with an anode and a cathode, make a very simple battery out of these electrogens. And Glavin, being Glavin, went a little bit further than that and was trying to talk about scalability and how much land area would it require to make his solar panels obsolete. He has big dreams. He always has big dreams. Can't fault him for that, but maybe sometimes he needs to bite off less than he wants to.
Sometimes.
Yeah, no, it's a strong mentality, but there's some. I suppose that's the thing that we're trying to accomplish, though. When you have those big ideas, you want to be able to break them down into more manageable pieces, because everything, maybe not everything, but things are possible. Big ideas are possible as long as you can find a way to break them down into small components. And I suppose that's the
dream.
That's the dream, to teach people or show people or even learn for ourselves a better way to do it. Like, we're always improving, always trying to find new ways to make things simpler along the way, so that when really challenging, really hard projects or really challenging, really hard problems get put in front of us or put in front of other people, the belief that you can do it and the tools and developing the tools to make those things possible is definitely the objective of the IntelliToys. Also, if anybody has any ideas or at least some direction for a name for this company, this product, oh man,
that would be beautiful.
IntelliToys. I mean, it's a cool name, but we gotta get something that's a little bit more. I want to say mature, but it's also it is for kids as well. But we want it to be for everybody. We want people to feel like they're included and feel like this is something that's a really good tool to use to improve your engineering abilities and to improve your problem solving abilities, not just toys for kids.
Yeah, exactly. It's something practical. That's something I've always noticed when looking around. It feels like a lot of these solutions are games. like these sandbox things. Like Minecraft, people have a lot of fun with it, but can I translate that to real life skills? And that's our goal here, is that everything you build should be buildable in real life as well. We just want to make you do that quicker, safer environment. Like, let's go and make mistakes, or let's plug in, create a bunch of short circuits and break a bunch of things and start some virtual fires, and then you can learn that stuff before you do it in real. So
Yeah, absolutely. One of our original ideas, speaking of blowing things up, one of our original ideas for the simulation, we started talking about like the limitations of, for example, I typically, most of my work is like medium to high voltage electrical engineering. If you make a mistake in that industry, like you plug the wrong thing in, basically, you can cause some really, really big damage. And to have the opportunity to have an environment where it's safe to make those mistakes, like a simulated environment, like what happens if you I don't know, connect a wire straight from a power line to physical ground? What blows up? What operates? What breakers trip? Things like that. I think there's an opportunity there as well to kind of get a sense of why we have to put so much thought into the preliminary engineering when it comes to those projects, and not allow for those things to go as wrong as they possibly can. Yeah.
all right. Well, thanks for waiting. I do have it up and running. So there's only one page that I really want to show a kind of comparison. Okay, so I'll start here. I'll start with the previous version. If you want to just show my screen, maybe.
I am.
Oh, perfect.
Yeah.
Awesome. Okay, so this is our Let There Be Light course. We're trying to build what you see in front of you, which is the essentially Raspberry Pi controlling this colored LED, light emitting diode, and you have a switch that you're able to toggle on and off, and it's powered by some battery packs. So this is the circuit we want to be able to create, and this course is free, easily accessible, and you can actually do it today if you go to intellitoys.ca. You can go start building now and sign up and start playing with it. So what isn't released is a kind of a newer version of the editor, but I'll show you that in a moment. So this is our current interface, and we want to walk you through how to determine what parts you need, and then go to connecting them together and coding them and things like this, all these various stages, and break it down piece by piece. So our first version, this is what's currently out, allows you to go and learn more about these different pieces, and we have a description here about what you're trying to achieve. So in this case, our goal right now is to select the appropriate components. So we want to have the components to build the electrical circuit to light up the LED. So the LED can emit red, green, and blue, so it's going to be full color. We want to be able to control it from Raspberry Pi. And yeah, so that sounds good there. And I think there's also a note about making sure we can turn it on and off without full Raspberry Pi control. So we have what we call a disconnecting device. And in this interface, you're able to click on these words highlighted in orange and actually see in our notebook some more information about them. So if we click on power supply, we can learn that this is something that supplies electricity to a load or multiple loads. And examples would be like wall outlets or batteries. We also have disconnecting devices. So for example, a switch, and you're able to, here's a diagram below. You have a line in from your supply, and then load would be, let's say, Raspberry Pi or a light or something like this. Yeah, so now in the course, this is our part selection. We want to go and take a look at each of these and say, is this pertinent? So we can go and say, does the Raspberry Pi, is that something we need right now at this current step? Well, our current step, we need to have power, a disconnecting device, and a way to emit light. So Raspberry Pi isn't pertinent yet. So we're going to say no to that. Let's go to the battery. Add the battery to the project. Okay, well, we just learned from going to the notebook that a power supply could be a battery. So that was pertinent. And now you've clicked it, and it actually highlights over here that it is correct. So we're starting to make our way down the requirements list. We look at switch. Again, we just read about this. Disconnecting device is a switch. Boom, good to go. We're at 2 out of 3. Resistor, electrical component used to regulate current flow in a circuit. Doesn't seem pertinent yet. Color LED, yeah, that sounds great. We want to emit light. Boom. There we go. So we're kind of celebrating being completed. And this is the first of many steps. Next is to be able to connect all these pieces together in a block diagram. And so we'll kind of we can maybe talk about block diagrams next, because that's what we're going to be doing later today. But just to show you a sneak peek of what's unreleased is a new version we're creating right now. This is after quite a bit of feedback and refinement. We wanted to have more of an interactive 3D tool for you to build full projects. So rather than this previous view where you're essentially given a new unique view every time you have a separate problem. So this problem is selecting your parts. We want to make sure that experience is that same experience all the way through. Like you're not whipping out a whole different tool every single time for each of these steps. It's the same tool. It's just different steps and how you're using it. So we have a 3D view. We have the same requirements that we have on the side. They're able to check them off. You have the same notebook that you can learn more. And the difference now is everything's in 3D. So I can go in my library of components and scroll down and say, all right, I need a battery. So let's go and add a 5-volt battery. Boom. And now it pops up in 3D. And you can see it still checks off the requirements like before, but I can actually take this 3D model and move it around in my scene and view it in different ways. And if I go over to 2D in the schematic, oh, it's not loaded right now, but I'm actually, if it was working, be able to see actually in the 2D schematic as well that it loads. So yeah, so that's that piece. Let's go to disconnecting device. So under connectivity, we have a toggle switch. Boom. Great. And emitting light. So under output, we have color LED. Great. Boom. You're all done. So this is the new experience that we want to have, where it's focusing on the same tool, consistent experience, and you're going from piece to piece using that same UI that you're experienced with. And you can do a lot more inside of it, such as you can see, 3D. And you can still do all the same things you like, but learning about different components and how to use them, and naming projects, or even taking pictures. Yeah, so that's kind of a sneak peek of what we're building right now in terms of the platform and the course building tools. Yeah, and then the block diagram editing. Let me just show an example. So this was a block diagram, like I mentioned, we did it quite some time ago, and we could do that. We could do something similar today, where here's a new project. I can go in and add. Let's say we're going to add in a Raspberry Pi. So I'm going to add this here. So now you see I have a Raspberry Pi that I can play around with. And if I go to this view, I can actually see the Raspberry Pi and all of the pins I want to connect to it. So let's go back to 3D a little bit. So let's move this guy around. I also have a battery source. This is 11, so I think it's a 12-volt battery in this case. Boom. So there's the big heavy-duty battery we want. Very cool. And again, you can see that we have the 2D view. So everything you want is all in one place, one tool. There's no separate tooling. Yeah, so it allows you to interact with each of these. And one thing that's coming out, and this is still in its infancy, is the idea of physics. We want to be able to build a car, but actually be able to drive it. If we have this, if you have all the parts, these circuit diagrams, we know how they're connected, we know how the software is written. Why can't we drive it? So if you see very briefly here, if I go to this view, you can see how it falls and hits. That's because it's actually physics for these components. They actually have a weight to them, a mass to them. So we're still fleshing this out, but in the end, we want you to be able to create an actual car or a drone or a robotic arm like we're going to do today, but actually interact with it and code it and send it to someone else and say, hey, can you try this? No installation required, you just send the link. Yeah, so that's pretty much the gist of it. And if, yeah, we have other components as well. So like, for example, these motor drivers, boom, again, you have the 3D model and you have your 2D version, so you can start to connect these together. So if we look at our previous schematic that we did quite some time ago, this is our previous version, and this is our new version on the left. Actually, I'm going to reorder these. So the past is on the left, and the future's on the right. And we can now go, let's say we got battery. Yeah, you probably wouldn't connect these directly, but you can see, I'm just going to go very quickly. This is not like real life, but you can see that you can connect, say, battery to motor driver, and I think this is probably not what you do in real life, but you get the idea. And you can connect something else like a motor here. So we got a motor, it's going to get power from the output. Yeah, so this doesn't particularly do much because you're just going right from battery power right to the motor, so it would just be spinning. But you get the idea. At least that you're able to connect these things and wire together and recreate this diagram here. And notice we don't have to do the laying out of all these parts. Like it's automatically trying to find a way to route them nicely. So we can instead focus more on what the meat of it is, which is, I know this needs to connect to this. You lay that out however is pertinent. The software will handle that. And if it needs to be symmetrical or whatever else, it will figure it out for us. we can just focus on connecting things really, really quickly. Yeah.
It's a great description.
Yeah.
I enjoyed that.
Yeah, lots more to come. There's still lots of stuff that's in development, but you can take a look at the course. Just go to IntelliToys.ca and take a look at the current version, and eventually we'll be able to publish the refinements that we have in the go.
Absolutely. There's quite a bit. There's quite a bit of text that needs to be modified, even in the existing course. I find that every time you look back at something you wrote in the past, you see some pretty significant mistakes, and it's probably just a maturity thing. Another year has passed where I'm writing a lot at work and becoming a better writer every day, and listening to my colleagues and learning quite a bit from them. So yeah, I suppose that if Glavin's ready, maybe we'll jump in and start doing some brainstorming for the arm, the design of the arm, and what components we think we'll need, and then we'll build a 2D model and a 2D layout diagram and a 3D model of the electrical components without the 3D models for the actual fingers or hand or cupper or whatever we end up deciding to do.
Yeah.
So with any brainstorm, with any brainstorm or any product, typically what you should do, or at least my perspective of what you should do, is not necessarily designed to find a solution. You look to find a solution. You look to a problem and try to solve the problem. It's usually the better approach, and that way you have constraints. Your constraints are developed by just having a problem in itself. So, for example, in our case, if our objective is going to be to, pick up a beer can, a full beer can from a stationary position. Maybe there's a fridge right beside the arm, and you just position the arm right beside the fridge, and the arm is capable of opening the fridge door, grabbing the beer, and rotating it 180 degrees to where you're sitting.
And just throw the beer at us.
And throw the beer. No. I don't think we'll be doing throwing the beer. Back to my civil engineering, my lack of civil engineering. I don't want... So there's two different... In civil engineering or mechanical engineering, there's two sort of very, very important concepts. One is statics engineering and one is dynamic engineering. Statics engineering are things like, bridges support things without moving. Rotating objects like a motor. A motor would be a bit more of a dynamic situation. Now, what happens with dynamics and long objects is those forces get amplified. Those forces on joints get amplified. So, throwing, in my very naive mind, sounds like something that might be challenging to do without tearing things apart.
We should probably just make it move first.
Yeah, let's make it rotate, do a thing, pick it up, one action at a time. Basically, as soon as you introduce multiple actions, there's multiple fail points, and every one of those actions have to be capable of sustaining the forces that are caused by the movement itself. So if you only move one piece at a time, you're going to have a lot better time. Yeah, that's my perspective. We also have to consider what sort of grabbing material. We're probably going to go down with, I would assume we're going to try and get some rubber pads for fingertips if we're going with a finger type solution. We'll get some rubber pads that are nice and grippy, or maybe even something. I'm assuming that people know what I mean when I say those gummy hands that you used to get from the dollar store, and you used to fling them at the windows and they would stick for a second. Maybe we'll use something like that. Do you know what I mean?
I don't think I do. Gummy hands from the dollar
store. So it's like it looks like something you could eat. You can't.
Don't recommend it.
But it's like a stretchy gummy material, and it's sticky, and it usually has like a tail on it, and it has like a ring hole, and you put your finger in the ring hole, and you take it, and you throw it, and it'll stretch up to 4 or 5 meters, and it'll grab onto something that you throw it at, and then it'll stick for a little while. Maybe we'll go down that avenue. Just an idea, just spitballing, brainstorming. I'll try and find that in the Googles.
Yeah.
Nonetheless, let's go to our Google Doc and maybe come up with some constraints that we would like to hit. Whoa. All right. Glavin's been thinking.
Do you want me to pull it into the big screen? Or maybe do it on yours.
Here, I'll pull up my screen. We don't need to see both of ours. We'll be writing in the same document. Okay. So, let's make an objectives. Can we write simultaneously even though we're both logged in the same account?
Yep.
Oh yeah, you can too. That's fair enough. Okay. Let's go with objectives. Oh, I can't spell.
Spelling is for English majors.
Spelling is for English majors. Sure. Sure. Yeah, that's true. Engineer's not not English.
Let's see who's in our chat or who's watching us right now.
No.
Does anyone have any ideas of what we should have for an objective?
So, yeah, what do we want to accomplish? I'm thinking, picking up something is probably a good goal. Picking up something from the ground.
Yeah, so be able to have the reach to be able to go to the ground and then pick it up.
And then rotate and place it somewhere.
Okay, we did talk about Jenga at one point.
Jenga.
The dexterity is challenging and the weight isn't too high.
Yeah, maybe let's do that. Let's go down that avenue. So we'll have to design a grabber that's capable of basically taking a Jenga piece. That'd be kind of cool too. Like if you're hanging out with your friends and Jenga tower falls and the arm can reach basically. If you had a table with lips so that they couldn't ever go outside of the reach of the arm when they fall, and then the arm could pick up anywhere within that box, and then rebuild the tower while you're hanging out with your friends, waiting for it to build itself.
I wonder how quickly. I think that'd be the issue. Is like how quickly you could do it.
You're hanging out, having a drink with your friends. You got all the time in the world.
Oh my god. Okay, so I the first thing is how would a human go about doing that? Is there like a tactic that when you're doing Jenga, do people just pick it up individually, kind of rebuild it, or do they actually fill it back in the box? Or
so the Jenga kit that I used to have, and this is how they all worked. The Jenga kit that I used to have it was like a rectangular block that only had two sides to it and a bottom. So you would build the Jenga block by continuously pushing it against this plastic block to make sure it had that nice structure. Yeah. You just kind of tighten it.
You're not just placing it; you're just like shove it against the wall, kind of thing.
Let's say you place it, you shove it in, place it, shove it in, but you're putting it in the right location. Now I'm thinking that the arm, in theory, depending on how much jitter we have, the arm in theory should be able to place it better than a human could, or at least more consistently.
Yeah, maybe. So from the robot arms I've seen, they get pretty jittery at the end unless they're very expensive. So that's what I'm concerned about. If that's the case, if we make the problem a little easier by saying, oh, okay, we place it, but then we like force it against the wall. So even if we're a little jittery, it won't end up just falling off or something like that. Like a human could build it up and just place it incrementally, but
if our first objective is quite honestly just building the tower structurally sound enough that it stays together, and then a human can come and put that piece of plastic against it to tighten it up.
Oh, I see. It's kind of like a little loose.
Yeah.
Okay.
Yeah, just suggesting. Yeah. We don't have to go. If you want to go further and say that the hand's going to be capable of having two hands,
it's just like working away.
I think a nice goal would be able to. And it's nice because when we get there, we're going to get to a point where it's too jittery to build the tower more than halfway, for example. It'll fall over because it's too jittered and it's too separated, but then we have refinements to make. And that's you get 80%, the last 20% is the hardest part of any project. Right? Yeah. The refinements.
You know what I just realized, though, is our cameras are set up so that they're in the opposite angles, so we're facing away from each other.
Oh, geez.
You see?
We can fix that.
We can fix that, and then that... Because right now, I'm talking to you, but it looks like I'm talking to the
staring off into the abyss.
Yeah, just like, ooh, engineering. Yeah.
Okay, I will fix it.
See, just like we're, this is what we do here. Behind the scenes engineering, we just fix everything live. Not ahead of time, not in post, live.
That's the point.
Yeah.
You're supposed to see all the hardships. That's the objective.
Okay, so I like that. I think Jenga's a good one. Is there any other things that we would like to be able to do? I'd like to think of a practical task. Like, at least Jenga, it's like, okay, cool, you have people over, there's some utility to it. And, look at me go.
You're flying.
I'm flying. That's great. How's the image quality for everyone? Is it, it feels a little bit light on my end, but maybe that's okay.
And this one, this view should be okay, because we're already in the right corners this time.
Oh, we were? Okay.
Yeah, cool. So, you got a little... I'm flying across the screen.
Cool. I like it.
Yeah, Okay, just got some minor fine-tuning here. Alright, that should be good. Okay. So, yeah. I think Jenga's a good one, because Jenga will require at least 2 fingers. at least 2 fingers, which is a nice grabber to build. It won't be able to. Well, with 2 fingers, if we had 2 fingers that could go 180 degrees separated, or even 90 degrees separated, you could even program it eventually to be able to disassemble Django effectively too. Like to play the game.
To play the one
because then then poke and grab.
It's gonna be interesting. Yeah,
that'll be tougher. Well, like even grabbing it out the side, right? It has a nice strong grip, pulls it in this direction, and then lifts it away.
It's gonna be I think even pulling,
that's the advanced version.
Yeah, pulling along an axis that is misaligned with like.
Yeah, that's gonna be interesting.
I would like to do some inverse kinematics. That's gonna be fun when we get to it.
Yeah, well, that's gonna be interesting because that means that the wrist will have to be able to move against the arm, so which is fine. It will be able to do that. It'll be a programming issue at that point.
We're facing the same version. Yeah. Okay. We got feedback in the chat.
Facing the same direction, we were looking apart from each other. Is that what?
Yeah. Make sure all the chat's working. Yeah, everyone feel free to use the YouTube chat because I think does that get saved?
It does get saved.
Yeah. At least I'd love to hear your ideas and thoughts and how we can.
Who's in there? Neon?
Yeah, Neon.
Nice. Good to see the Neon.
It isn't working for Neon.
The chat is not working for Neon. Interesting.
Okay. We'll keep plugging away. We'll figure that out in a little after.
Yeah, in post.
Yeah. Cool. Yeah. So I think so Django's a good one. What other practical things like?
I mean, picking up a beer. It's always useful.
Just picking up, putting it over there. Like, how big is this arm going to be? Should we put that? We just shove the arm on the car.
Shove the arm on the car.
How top heavy is this thing going to be?
Yeah. I think my perspective is we run with the Django, and we build an arm to prove that we can build an arm, and then we come up with some real objectives for the next arm. Because similar to the car, right? Remember our first prototype for the car?
Oh my god, it was so bad.
But it taught us a lot.
Yeah. Yeah, that learned quite a bit.
Second iteration is usually the better experience.
We need a way to be able to pull up those old videos and be like, oh yeah, remember this time? Like, here's this piece of crap car we built the first time.
Yeah, exactly.
Wiggling around.
Wiggling around, yeah, and you spent, 3 hours trying to fix this?
I was so mad. That thing. All we wanted to do was, like, go straight. Like, literally, that was it. That was 100% the goal. We couldn't do it.
Yeah, go straight. No.
It was like hard left, hard right, hard left. Oh.
Cars don't go straight.
No, not this car.
Do we have the car? The good car? We can show it off.
The good car. The good car is I think in the closet there actually.
Yeah. I will be right back.
Yep. Yes, gentle. Oh. Watch to your left. There's a light there.
Oh, both cars are here.
Careful now. Only one of them will work. I don't know how to flash the other one.
Oh, I'm not going to turn the other one. Okay, so they've been slightly disassembled. Actually, I don't know what the heck
that's
is going on.
Fine. No, that one should be fine. That's the old car.
This one is in bad shape.
That one's in bad shape, yeah.
So, this was our original car. This was one night, I think it was a Saturday night. Glavin and I hung out at my place, and we basically have an ultrasonic sensor to try and get the car to avoid running into... Actually, use your camera for this one.
Oh, is this... Yeah.
Yeah. So we put an ultrasonic sensor on it. And obviously, everything's in the wrong location right now. But we had an ultrasonic sensor on it so that it could drive and avoid walls and turn away from walls. We had a servo that controlled the front wheels.
Which is... front wheels are... here.
It's on... Yeah. And then we had an Arduino to actually program the functionality. And I mean, from my perspective, it worked really well considering we had an old RC car that was torn apart. We had some breadboards, like actual electrical garbage. And then
I've seen nicer tracks.
We made some modifications and we bought a new frame for our car and we built this.
It's a V1, V2.
Yeah, you can take that as well.
We can use your camera too. I'm going to show them at the same time.
Yeah, sure, okay.
We need a view with both cameras and big screen, or we'll get there.
Yeah, we'll get there. So this car, again, they're kind of a little bit of a mess right now. We haven't used them in quite some time. Oh, Neon got it working. That's great.
Oh, excellent.
But yeah, so this component on top of the car is actually a radio transceiver. So it's a receiver for a controller that we also built, which I think is nearby. And I'll show you the controller. It's pretty pretty rough.
It's in one of those shells. Here, I'll take this.
Yep. Show it on that camera.
I see why, because you don't want the background removal.
Yeah, the background.
Yeah, so this is the new one. You saw version 2. This is the new guy. Nice metal shell, Mecanum wheels, very fun to play with. You notice these guys? These were actually the motor drivers. If I go into the app and click motor driver, is this like familiar? Boom, same thing. So we're actually able to rebuild this car in our app currently. Very similar switch, everything you need. But this is a lot easier to drive versus the one that we had previously. We talked about these front wheels. So this would either you couldn't actually tell it to turn. It actually had a motor that you'd say, go power on, power off. So we actually had to time it to make sure it wasn't too hard left or too hard right. So what ended up happening is it would kind of snake its way through a little bit and made it very difficult to drive straight. Perfectly fine to drive right or left if that's what you wanted. But yeah. And then this, I think in there is the printed version somewhere. This,
I think it's on my plate.
oh, it is. Oh, I was going to mention bringing it to that. That's fine. This is our first version of the radio frequency transceiver, right? And then we had, so this guy has a battery pack in the back here. You can see I'm just trying not to break the thing. So battery pack, all wired up, everything made from scratch. We're literally using little pins to hold in the controllers. And what are these? These are PlayStation 2?
PlayStation 2 joysticks, yeah.
So that's pretty sweet. So completely custom Arduino Nano with custom firmware. So this right here remotely controls this big guy here. So you're actually able to drive around effectively with a custom PlayStation 2 controller that we built. All wireless and a lot of fun because the Mecanum wheels are kind of neat. Like it's very unusual. When you're driving like one of these cars, it's like when you get on the road, right? You're kind of swerving left and right with your steering in the front. And you're going to get pushed. With the Mecanum, you can actually strafe. You go sideways and move around and translate, and you can spin. And it looks. As anyone's watched iRobot, I love watching that movie for the car because when he's in that scene, he's just driving down the street and he's like, "Oh no, I want to spin to get all the robots off me," and he just like starts. He's like going forward and spinning at the same time. You could do that with this.
Yeah, you can legitimately do that.
Which is nuts. And I've always wanted a car to do that. We have it now. Mission, like, life goal completed. So, so inspired by iRobot. Hope we don't get banned for saying that. But, but yeah, so it's pretty cool stuff. A lot of fun to play with.
One of my favorite points in time. So working with Glavin is an interesting experience. He likes to fight back on ideas. For example, we were using a PlayStation 4 controller originally to control that car over Bluetooth, which worked really well, except for the fact that Bluetooth on a PS4 controller only works about a quarter of the time.
I hate Bluetooth. Oh my god.
So I proposed to him that we design our own RC controller, and he fought back and talked about how much, and now he thinks it's the coolest thing ever.
He didn't have to convince me. It was great. It was great. It actually wasn't too challenging either.
And it works perfectly.
It works.
You just turn on the switch.
It works really well. Yeah. Turn it on, get them both running. Like essentially, the only part, this isn't set up to auto boot, like it's a Raspberry Pi, but really you just turn on the program here and you just put in the battery in the controller. That's it.
Because we don't have a switch.
Because we don't have a switch, right? we need to get another one of the switches that we have here. But, with some more CAD work and some more hardware for the switches, perfect. You just have everything switch, good to go. Mm-hmm. And it would be like you bought it at the store. The cool thing is we built it ourselves. And hopefully we can learn some CAD and actually build a different shell.
Yeah.
And make it
get some customization. Yeah, we're still pretty fresh in using. We were using what was it? Fusion 3D.
Yeah, Fusion 360.
Fusion 360. Yeah, Fusion 360. We're using Fusion 360, and I mean the software is reasonably intuitive, but there's some really big quirks. Like it feels good, and then all of a sudden there's a quirk that takes you hours to get through.
Yeah.
So there's some hurdles, but I mean honestly, like anything, a bit of time will get us to a point where we're comfortable with it. We did 3D print a case for that controller, but I made some mistakes in measurements and we had some better ideas about how to mount some of the equipment.
Yeah.
So there'll be a V2 soon enough.
lots of iterate. But the nice thing is, it's all in software, so it's easy to iterate.
And just to show you, here's you can see this on IntelliToys.ca. This is actually what the car looks like in virtual. So all these parts we have access to in CAD, and people can build stuff with it and wire it together. And yes, take a look. We got that's the virtual. This is the real. We want to make sure you can make your own digital twins. And yeah, we're getting there.
Yeah, we're getting there. Thank you.
No problem.
Appreciate it.
I'm holding. This is hilarious that this thing still exists. I thought we had disassembled it already.
Well, it's pretty much disassembled. It's almost disassembled with everything stuck to it.
Yeah, pretty much.
Electrically, it'd take quite a lot. It'd take quite a lot to make that work. You know what? Actually, a lot of the stuff's still connected. Anyway,
It's seen better days.
is that my Elon Musk book?
Maybe.
Why is that here?
Maybe.
It's also my Arduino book.
Maybe.
Yeah, you know what the sticky hand is, right? Yeah, I'll see if I can find it.
Someone recognizes.
Sticky hand toy. Your screen's still the one that's showing for your information. This thing, I literally Googled sticky. Watch this. I Googled sticky
I
hand
think
toy.
I've seen that.
Of course, you've seen it before.
That looks really good. You think that that's something that would stick in my memory? You're hilarious.
It's a sticky hand toy. Everybody, no, neon right away. Boom, sticky hand toy. Absolutely.
Remember very different things.
Look at it.
Now seeing that I don't think I've actually ever touched one. I don't think.
What did you do as a kid?
What's in the closet? No, just build stuff.
Just build stuff. All right, fair enough.
But yeah, no hardware. That was the problem.
So what do you think? Do we go with Jenga?
Jenga's a good one.
I think it's a good goal.
Yeah.
And we can adjust, because, I mean, realistically, aiming for the dexterity to build a Jenga tower will also provide us with the opportunity to have the dexterity to do other things. We just don't know what those other things
And
are.
we'll fail. There's no way we're going to hit Jenga on the first try.
There's no way we're going to hit anything on the first try. The arm's just going to fall over.
It's going to fall over. It's going to be hilarious, too. We'll have, like, a big stand. It'll be like, and it's going to, it can't hold itself up. It'll be like trying to arm wrestle air, effectively. Or
Okay.
gravity, I suppose, more appropriate, but yeah.
Build Jenga. Build Jenga. Let's say build Jenga. We'll say confined area. What would you call that? Neon, maybe you would know. Until they get stuck in your hair. Absolutely. Good thing I have short hair now.
I wouldn't say that, but okay.
So, Neon, you may know what I'm talking about when I say it's probably a serving tray, like similar to what Combat Corgi has, where it's like it's a serving tray, but it has edges. Is it still called a serving tray?
Serving tray that has edges. I know what you mean. Really, just need a box to make sure it doesn't fall out, right?
Yeah.
Actually, we could.
Like something like
Just a container. It's like a cup. It's effectively just a big cup.
a big cup, yeah. So I'm thinking something something like this, so it has full 360 and the arm can reach everywhere in that 360. And then basically bring all the blocks back into the center.
I like that.
Yeah. Confined area limited to.
I'd put that screenshot in, actually. That looks like a good. We could literally just buy that thing.
Yeah, maybe we will.
I'm sure it's a serving tray. It's nice.
Serving tray.
Now, what I would like to have, now this is not for the arm,
But we really should get to a point where we can plop a serving tray on top of the RC car and have it drive like beers to us or something.
The arm sits in the center of the serving tray, fills up its serving tray, and drives it over to you.
Perfect. Yeah, we attach them both.
And to be honest, having a serving tray at the base of the arm would probably give it a little more stability on the car because it gives it its center of gravity gets distributed.
Yeah, like at least our car right now is made of like a little stronger, heavier materials.
It can drive with something like 10 kilograms on it.
Yeah.
Like those motors are powerful.
Exactly. I think my concern would be less so that it can drive and more so that it doesn't tip over because we put the weight center of mass up too high. But if we can make it so that we can put the pieces together, like imagine a portable Jenga.
Why? Why would I need to imagine that?
You can have it drive through the table to go to someone else wants to play Jenga down. No, I'm kidding.
Oh, jeez. Defy gravity. Don't fall over.
Yeah, I just want to make that clear. Like that's a need. If you can play Jenga on its side.
I'm gonna put just for just since we talked about it, I'm gonna put build Jenga, potentially play Jenga in the future.
Potential
Play it.
playing check. Oh yeah.
Future goal. Cool.
I think to do that though, so like when I'm playing Jenga, I often want to get 360 around it. So like, okay, I think the only way we could do that would be we mount the arm on something that can rotate around a focal point. So like it's an arm that faces inwards, but it can also face inwards from any direction.
I see what you mean. That means we'd have to have a physical interaction before we can build the Jenga. Well, I mean, honestly, what we could have. So now this is getting complicated. Now we're designing a serving tray.
Perfect.
So we have a serving tray. Serving tray has two pieces. There's a centerpiece that doesn't move, so we'll call that the stator. And we have a rotating piece on the outside. We'll call that the rotor. You mount the arm to the rotor, and the rotor is on a servo motor that rotates the rotor piece of this circular object. Can you imagine? Do you know the theme park ride called the Roundup?
Roundup and it's movable. Roundup, right? Oh, it's like spinning but also moving, like up and down.
Yeah, so I'm not worried about the moving up and down. I'm worried. I'm thinking. Okay, so we have this rotating piece, but then now imagine Roundup with the centerpiece stationary, so only the outside moves. So you mount the arm to the outside of that rotating piece, and now it can go 360 around the Jenga
That's what
tower.
I'm thinking. Yeah.
And then we don't need to worry about that serving tray being the arm doesn't have to be in the center of the serving tray because it can as long as it can grab pretty close to straight down from where it's at.
Yeah.
It doesn't have to be in the center of the tray. It can reach anywhere in the tray, but from one point instead of having to go 360.
Reach essentially the full diameter of the tray.
Exactly, and then that means that you would only have to have we'll still make it a 360 base, but that means that you don't have to be able to rotate in a full 360 degrees. You'd only need to rotate about 90 degrees.
Yeah.
From the base.
Interesting.
Anyway, we're gonna start with the hand. We're gonna start with.
I would like it to move. No, yeah.
I'd like. Okay.
How build Jenga? How many pieces? We're just carrying one piece at a time. How heavy is a single Jenga piece?
I will. Let's find it.
And what? Yeah, because we gotta figure out a gripper that would do for it.
Weight of Jenga piece. Jenga block. Perfect. 10.6875 grams.
Okay, I think the answer is tiny.
Yeah.
Okay.
Insignificant.
What we would like to carry later to make sure we size our motors appropriately?
Yes, that is a great question. But before that, I'll entertain that idea in 1 second.
Entertain me.
Confined space. Perhaps mount arm to
I wonder if there's any universal mounts we can use.
of a serving tray with stationary center to allow the arm to circumnavigate. Is that the word?
The globe. Yeah.
How do you spell that? Navigate. That's not.
There's a lot of like spelling in this video today.
It didn't tell me I spelled it wrong. That's good.
Oh, really? Good job.
Circumnavigate.
I think it just gave up with you though.
Well, it says I spelled center wrong though.
Oh,
America.
Oh man.
Allow the arm to circumnavigate the Jenga tower. The arm will reach. It will have to reach the diameter of the tray and nearly straight down. We could have to avoid having the blocks go too close.
We just move it out then. Make the radius of the rotor arm further out. Right?
We can make it further out, and then we could put in the serving tray. So we have our serving tray, and we have our rotor rotor piece, and then we have a circle around the arm so that the blocks can't get too close to the arm. And we'll design the size of that circle around the arm, whatever size is required to make sure that the arm can go down just outside.
Oh, I was thinking the arm would be outside of the tray. Like what
You would like a second. You would almost like a second wall around the entire thing, so that no blocks can go where the arm is.
Yeah, like I was
Fair
saying, so if we have this confined area you have in the diagram in the right here, I was thinking that's completely empty, and like the arm is outside of it, like rotoring around it.
Okay, that makes sense. I like that.
That's just super clean. We might want like another circle, like another wall around it, just to keep the arm safe, but like that's separate.
Yeah. Outer ring. Let's call it the rotor again, just for lack of a better term. The rotor will be separate to the serving tray. And we'll say, as in, the rotor will be outside of the wall of the these little brainstorming things. I definitely get a little too wordy when I'm writing stuff like this, but it's just because I'm not stopping myself to think about how to write properly.
That's right.
I'm doing, tight word vomit. I
Better
guess.
to get ideas out first. Okay, so we got that piece, and then I'm just mocking up roughly what we want here. Do you have an idea of how big we want these things to be?
Oh, you're already going for it. Ooh, I'm gonna pull up Glavin's screen.
Send you a link for this.
Yeah. Oh, yeah. You guys,
yeah.
we didn't even talk about it being multiplayer.
Oh, by the way, it's multiplayer. I think I sent the link already. Arm Project Sandbox in the doc.
In the doc, Arm Project Sandbox.
So fingers crossed, multiplayer works, but find out.
Okay, I'm actually gonna just for a moment. I'll leave it on Glavin's screen after I show something off a little bit.
You could show both screens because like we're at different angles right now. Like just to show off the fact that like I can go and move this and edit it, and it's moving on your screen and my screen.
Yeah, so we're in my screen would be the bottom right, and Glavin's would be the top left, and it's showing that we're in a multiplayer environment, which quite honestly means that we can both work on designing this together. I have a question for functionality. The better way to do this wouldn't be to use a square; it would be to use a circle and hollow it out.
Yeah. I have no hollowing means.
Okay.
Yeah, so that's it. So I want to make sure this tool doesn't have CAD stuff, at least for the most part. So if we want to make actual CAD objects, we can import them.
We could import
from some other tool.
But if we want like even basic shapes, we should have some way to do that. Because right now you're gonna.
It's a slippery slope. As soon as we say, "Oh, I want like extrusions or something or whatever," like we just keep adding. So
sure.
I just kind of said, okay, well, I can support as many file formats as we want, and a bunch of other tools already support extrusions. Like Tinkercad, or there's a bunch of others that I know that are being worked on that can do simple CAD stuff.
Sure. Okay. So in that case, you should be working on this in something else. So you're not going to be able to make that shape.
Yeah, we could. All right. Well, let me show you something else that's neato.
I don't think
I can do splines. Yeah, I think you're right. I think you're right. Yeah, that sounds good. Just I'm gonna work right here. I'm trying to remember. I've added so many things and I've broken more things that I can't remember what features still work. This is the problem of moving past and breaking things. You break a lot of things.
Remember when we said we were going to start at the hand and work our way back? You're designing the base.
No, you started your hand for your motors and stuff. Your side motorizing. But
sure, yeah, that makes
like
sense.
the arm is still gonna look like an arm, and that's all I want to do is just visually represent it.
Yeah,
but yeah, definitely.
It's funny. Here, I'll sketch something up in Tinkercad right now.
Cool.
Is that fine? Let's use Tinkercad.
Tinkercad's good. Was it support OBJs?
Tinkercad. Let's see. Personal. Google. I'm on behind the scenes. Yep, cool. Ooh, I get to show off a couple of my designs from previous.
Yeah.
My controller. How do I open this? Tinker this. Probably that button.
Actually, yeah, you can show the controller. Oh, actually, I could even show. Yeah. All right, you show that, and I'll show you what that I was able to do with that.
Here, check it. Check it. Here's my controller.
Make it big screen. You can show people.
Okay. Green. Yeah. So here's the controller I designed to replace the one that we made out of styrofoam. This is I designed the joysticks just as placeholders. Same with the RF transmitter, just so that I could sort of design around them. This is what I would actually print. The base and the top for that controller, and I think it's actually ready to print. Maybe not. I don't have a battery. I don't have a space for the battery yet. I remember I was ready to get you to print it, and then I was like, oh no, I don't have a battery.
Yeah, let me show you what I was able to do with that. So this is in our software.
Let me switch back to your screen. One second.
So you saw the CAD stuff that was made over there. This is importing the CAD as models, and now we're able to just place them. So here's all the models for like the receiver, the joysticks, the actual CAD that was just created in Tinkercad. Yeah, all coming together. And I think if I go like this and do this, you kind of collapse on top of each other and kind of see what it looks like.
Oh, very cool.
So now you can actually get a better feel for it with the real pieces.
Yeah, the pieces when you look at my Tinkercad version of it, the pieces are actually just freehand drawn, but the pieces that Glavin has are the proper pieces that we use in real life.
Yeah, and that's the hope. And in the long run, I'd actually like to have VR support as well. So you could do something in CAD, import it from various sources. So our 3D printed work that we're doing, the real CAD files for all these pieces, and then you actually put it in VR, put it on an Oculus Quest 2 or whatever, and then actually just put your hands next to it and be like, yeah, that feels good. Like,
yeah, that's sweet.
That's the goal. Everything comes together. And again,
yeah, Oculus, right?
Yeah,
right. I forgot all about that.
Yeah,
and
it's multiplayer.
And
right?
it's multiplayer.
So we could have someone doing CAD, which then we import into here. Mm-hmm. We lay that out, and in real time, you're seeing it in front of you in a thing that you're able to touch.
Mm-hmm.
Right.
Mm-hmm.
Yeah.
No, I don't. I'm just, to be honest, I'm stuck in my own head now. I'm thinking about why I didn't add a battery. I must have, when I sent it to you, I must have said that, shoot, I didn't put a battery in this.
Probably. I think there's a few things that we realized after the fact.
I think it's pretty close, because I took all your advice. I made, look, if you look at, here, I'll show you my screen.
Yours newer, yeah.
Here, so if you look at my screen, it might be easier to look at it on my physical screen.
1 sec, yeah, I'm going to move over. Saving this. Cool.
Yeah, so I took your advice and basically updated all these. I widened these so that they won't snap as easily. I made it so that the base is a little bit more flat, so it won't have those weird ridges.
You should send that to me. I want to test it.
I have sent it to you.
Can you do it again? Put it in the dock and I'll open it up.
Okay. Do you want the whole file or just a piece?
I just want this a pieces, because if I have the STL for the top and the bottom, I can import into there and you can just see what it looks like.
Here, try and grab it. Okay. Yep. This will take a second. Export.
Yeah, they can see your screen. Perfect.
Okay.
Actually, just to demonstrate that, like this our tool isn't going to have everything. We want to leverage the best in class for other tools and work together.
Mm-hmm. Do we have a 9-volt battery model?
5 and 12.
Right, we should get a 9-volt 9-volt battery model to see, so that I can, before we print it, we can see if whatever I do fits the 9-volt battery.
It was a real, like the single batteries, right? Yeah. Let's take a look.
Here, I'm going to give you, while I'm exporting these things, I'm going to give you Glavin's screen.
All right. I'm going to show them Sketchfab. Sketchfab is fantastic. So I just search up 9-volt battery, downloadable. Any of these look promising? All of these look promising. These all look great.
Perfect.
Like, look at this beautiful thing.
That's incredible.
FFBR, physically based rendering materials. So this is going to look fantastic. Just like to load. I'm pretty happy with this. How do you
Yeah, that'll work. That'll do.
That'll work. Beautiful, right? So like that's the great thing. Sketchfab, 100% recommend. Like we want to make sure we integrate with each of these, make it super easy. I'm gonna just download like a lower quality texture file that should be sufficient for our needs. And cool. Give me a second. I'm just gonna.
Oh, right. I remember how to do it now. I haven't been in Tinkercad in a while, so I couldn't remember. The reason I gave you Glavin screen is because I couldn't remember how to do this.
Yeah, that's fair.
Let's go export GLB. It does export GLB.
Oh, really?
Yeah.
Oh, that's
yeah.
perfect. I prefer GLB always. Cool. So if I'm gonna do, I'm just gonna make a duplicate project so we can see the new one, improved version.
GLB. Showing folder. Let's rename this.
Put some stuff together.
I really don't like Windows 11.
Tell me more.
That's it.
That's the suite.
RC controller base. And then let's go.
Okay.
GLB folder. We should get a glass case for that car. Tidy it up a little bit, get a glass case, and put it on a shelf.
The old one or
the new one?
Yeah, okay.
Make it nice.
I still want to drive it. Okay. So this right here, I'm able to go in, I just hit upload custom model, and I have a folder here for model, so I'm just gonna click. Give it a second. This works.
Where can I send you these GLPs?
So this guy. Take a look. So now we have this one. Put it in our shared drive, and then
okay,
and I'll just open them up.
I don't have Drive open. Okay.
Well, that's what we're using.
No, I have Docs open.
You're hilarious.
It's okay. I'm in Drive now.
Okay, so we got this guy. Cool.
Drive.
So let's say I want to resize this. I need to go 9-volt battery. How big? 9-volt battery for realsies.
An inch and a half.
Really though. I got everything in like meters.
Sorry. New folder GLBs.
I'm just gonna make it like this. This will not quite be to scale, but I think it will be pretty damn close.
Okay, I put those in a drive under behind the scenes in a folder called GLBs.
Are you screen sharing mine as well?
I'm screen sharing yours, only yours.
Oh, only one. Okay. So I got 9-volt, check. Other stuff, check. We're gonna get the updated files. Let's see.
Okay, now that I've done that, I'm gonna go back and start designing I'm gonna design the base, right? For the base for the, yeah, that's what I'll do.
Yeah, in Tinkercad or whatever you like. Yeah.
New design.
Tinkercad sounds good.
Yeah, it's fine. It's nice, easy.
Okay.
Easy.
So we have a folder here that we're gonna just download a bunch of these guys.
Yeah, I'm gonna do a split screen since I'm drawing.
Yeah. And that's the goal. We want to like maximize the collaborative efforts here. So he's doing some CAD stuff. I'm kind of pulling things into the system and tying it together, and we can kind of meet in the middle.
I wonder how I changed the settings of this.
Figure out this
Tinkercad.
Now I'm gonna go and upload the new file.
Where's Turing?
So I got a base.
Robot Arm.
Okay, we're size. So here's the new one. So the sizing is a little bit off. We'll fix that. And I have another one. but it's looking really good.
It goes in so nicely. Wow.
Did you like that?
You should have seen the incredible amount of work that was required to bring in a 3D model. What, 6 months ago, 5 months ago? You'd have to go through actual code base and change probably 6 files along the way and convert a file to GLB, and he just dropped it in. That's incredible.
That was the goal.
Like anytime you see a piece of software that you're like, wow, that just works really nicely, you need to understand how much effort it takes to make something that easy.
It definitely took us quite a while to be happy with it.
Oh man, I'm psyched.
I'm glad you're done with it. That was definitely a really important goal.
Yeah, one of the ones that I had to fight you for again. You're like, oh, that's not important.
What? No, I said it was important. I just needed more time to do it.
Ah, okay, fair enough.
And then I got more time to do it.
Fair enough.
Turns out hard things take time.
Do you have? Yeah, no, that's absolutely true. Do you have a ruler?
Do I?
Or a
yeah.
a measuring tape, something,
Somewhere.
or even something that you know the exact dimensions of?
That.
Just think. I'm just trying to
You're
think.
asking the wrong person. I don't usually deal with physical. And the person you need isn't here right now. We will find something for you.
That's okay.
What are you trying to measure, by the way? How small?
I'm not trying to measure anything. I'm just trying to. I'm trying to visualize how big this should be.
Oh, okay. I see. Well, we have a visual tool. We'll
Yeah, but there's no not for that, for the base. Like yay big.
I guess it depends on, like, if we make it too big. So the thing is, we're gonna have the arm outside,
Yep.
and therefore it should at least reach. Do we want to reach the full way across, or just reach to the middle at least?
Oh, I guess it only has to go to the middle. That's a good
Middle, I
point.
think, right? So from wherever we have outside, so it might be bigger than the radius of that circle, because we're gonna have another radius, which is what the arm mounts to. So it's really the arm mount radius to the center. Okay.
Yeah. Okay. So
And how big would we want that? Like a foot? Maybe a foot's too big.
foot's probably not big enough actually, because for the centerpiece, because
Right,
like
foot.
you got to what you got to think of is how far will a Jenga tower block fall?
We should watch some Jenga videos.
Oh my laser, no.
We should recreate some Jenga seed out there.
Do you have Jenga?
Probably. I don't know where.
I'm gonna go take a look.
It might. If I have it, it's either there or in there or downstairs or in the.
I'm not going anywhere.
He's no longer taking a look.
Okay, let's say this would be a 2-foot diameter here.
That sounds fine. That sounds a lot. I don't know if we can make an arm that reaches 2 foot.
Well, we'll have to be able to reach 1 foot. You just answered that. You just came up with that.
1 foot sounds good.
Yeah. Okay. So 2-foot diameter to have a 1 foot reaching arm, and I need to know, like, does this have dimensions? It must. Oh, this is in SnapGrid is 1 millimeter, so it's in millimeters. So 60 millimeters. So I want this to be 600 millimeters. Oh. Okay, we're making this bigger.
So
So
you're still watching both their screens? This is cool. I'm glad we're doing some live stuff.
yeah. Wait, actually, each grid is 1 millimeter. So let's do this 5 millimeter. 5 millimeters. What do I want?
Your screen is
6
computer wailing away.
Wait, can I like rescale this somehow? I must be able to. I'm gonna have to Google this. Actually, let's just make this stay in metric. 600.
Why go? I'll line it up.
Let's make this 1 meter. 1 meter.
Eventually, I'll add different ways to make this a little bit easier, but for now, I have to do this way.
Big grid. Okay, so now I'm gonna put you at 0, 0. So this should be 600 millimeters by 600 millimeters. Yes, 601. What? No, don't do that. 600. It's just a dumb mistake. Okay, so the inner radius is going to be 2 feet. Running with it. This is just demonstration purposes anyway. But for now, it'll be 2 feet. And then we're going to make another circle. Cylinder. That will be... How wide do you want the base of the arm to be? It doesn't have to be crazy wide as long as we plan to bolt it.
Yeah, let's definitely plan to bolt it. Basically,
What about, so this would be 20 centimeters approximately, somewhere there.
gears going on that. Would that we want to put at the base of the arm like
A Raspberry Pi and all that gear there.
That makes sense.
Okay.
Yeah.
I guess the only disadvantage there is that means we're actually the rotary will actually have to move that weight around.
That's fine.
But that's okay.
That's fine. We'll just put a big motor on the
It probably makes it better than having to run wires to do it remotely through the rotor.
Yeah, yeah.
So like then, okay.
Yeah, that makes good sense to me. So we'll do it all in the base of the arm. So I'm thinking 20 centimeters by 20 centimeters, so like that big.
Yeah. Okay.
Cool. So I'm going to make this circle 800. 800 millimeters
All right.
by 800 millimeters. Take it, center it over top, put it here, raise it up. Take another circle, put that over top. So this circle is actually a cutting circle. So I'm just going to hollow out the center of this one. So it's an extrusion. So this will be 600 by 600. That will also go in the center. But I would like everything to be centered over 0, 0. I'm gonna Google. I've been guessing things, and I gotta stop guessing. Tinkercad, add, um, accurately moving objects.
Yeah.
Because I'm just guessing. I'm like eyeing things, and it's not appropriate. I don't want to watch a video. How to move objects. Step 1. Move, go, to find the burger patty. Making it just before it's position the camera.
One disadvantage of the GLPs, it has the materials included. So something I want to add in the future is.
Are those all accurate and scaled?
Mm,
No, they can't be.
Not really. I'm gonna have to fix some stuff. Yeah. I did add something to help me with that though. Here, I'm now able to like see the dimensions.
Okay.
Because before I couldn't do that, so I'll now I can actually scale things a little better.
The reason I ask, and the reason I wanted you to put that battery in there, so that I could see
the
how much
battery
space we have.
Yeah. But now I will be able to do that. One thing I want to do in the future is be able to have like a materials editor. So we could say like, oh, like that's a piece of metal. Let's make it a metal material that's shiny and interacts with like the same. So like all of these are pretty flat. I'd like to be able to say, oh, that's rubber, that's metal, that's this, and that's 3D printed, which has a different texture of its own. And then you could do something where it's like photoreal.
This is why you don't lock things. We tried to lock our courses. They lock the courses. You have to go through it. That's so frustrating.
What is this?
It's Tinkercad.
Oh. But it's probably not locked because you have to go through it linear. It's probably locked because they want you to sign up.
Maybe.
Yeah.
All right, I'm going back to just trial and error.
Do you know what the size of these guys are? I'll actually change them to be their correct size.
No. You can probably Google that. Amazon would probably have the answers. Center object at 0, 0 center. Object in Tinkercad.
We got this guy.
Align to reference. That's what we want. Okay, let's give that a shot. See if that'll work. Let's grab everything and go Control L. Nope. Select two or more objects to be aligned. Press the align icon or use the L key. Oh, I pressed Control L. Whoops. L. No. Stop. Stop. To align two objects, select them both, press the align icon, or use the L key, and you'll be able to choose the nodes, two objects. It's frustrating already.
Oh, what's happening?
I just suck. That's it. I don't even want to explain it. It's so frustrating. Control L. Okay, now let's try it. I don't know what L did there. L, align. Perfect. Okay, let's align some stuff. Okay, I need to figure out how to work this.
Some of these things.
L. Everything.
How's that?
Wow. It's very good. The battery is way too small. The battery is actually, I'm actually thinking I'm going to make a slot for it underneath.
How I'll go back to it. I'm just eyeballing it right now, but
Okay, and what do I do? Just place where the select two or more objects to be aligned. Press the align icon or use the outlet key, and then select the object you'd like to use as a reference. You'll see that alignment nodes now appear around the reference object, which stay in place while the other objects align to it. Okay, yeah, that's what I did. That's what I want. It works so much better for them. So I go bam,
You can select the other photo.
and I want to align it here. Oh, okay, that worked. Cool. And then I want to align it here. Okay, did that work? Looks like it. Okay. So now I want to align it. Align L. Align it here. Nice. That's great.
Cool.
Figuring stuff out.
Does it keep it aligned? Or is it just temporary?
Keeps it aligned.
So it's like chained there. Okay, cool.
Yeah, so that's great. Well, I mean, I can still move it. So let's drop this down. Let's make. Oh, I'm actually resizing it. I don't necessarily want to do that.
Does anyone in the chat have any questions about what's going on?
Yeah, we're kind of rambling, or at least I am. Probably not giving a strong description of what I'm trying to accomplish.
so this is just the old ones to demonstrate that we can create the controller.
Okay, so
Model. So this is just our controller that we saw earlier, just to demonstrate that we can take a CAD file and bring it in.
like this 605. 605. Okay, and then actually let's make it 610. 610. 10 millimeters, 1 centimeter. Yeah, 610. And then let's click here.
There's your controller.
Nice. That looks great.
Take the top off. There you go. Again, this is all physics. You can see the piece bouncing around. Take a look at this. Because they're boxes, so they're colliding with each other right now.
Huh.
But and the scale is off. It's currently 1 is equal to 1 meter, which is wrong. So it's and you can notice here the bounding box. Here's the bounding box for each of them.
Yeah.
So I'm also
They're a
working
bit
on
too
another
big.
tool. Yeah, I'm working on another tool that's actually gonna be able to take this and then shape it closely. So then you'll actually be able to import something you just created, physically represent it in the physics engine, plop it in, and actually have things roll off it appropriately. Like we'll be able to see these holes and things will go through it, and you can actually physically place things. And that's going to be useful down the road when we have the VR support, because you'll be able to actually have 3D things you just created physically represented as digital copies in the digital world that you can now interact with this way or in VR, and you can take your hand out, poke it, and it actually would move away, or you can pick up little pieces. And ideally, I like the joysticks, but they interact with it. Like if we could build a joystick, but then you could pick up the virtual joystick and like click in the buttons or move them around like joystick things, should be possible. But that's down the road.
Sure. I'm still trying to. I don't know what's going on. Oh, it's locked. How do you unlock that? Oh, I see. Interesting. That's weird.
All right.
So I want this to be 810. This to be 810. I want to make sure that everything is aligned. That's L. Make sure that this is aligned and this is aligned. Okay, and now we're gonna actually do the extrusion. Boom. Look at that. Beautiful. Now we're gonna align the two pieces. And they're gonna go down to here. Look at that. Boom. It is not aligned. Alright. So now let's try that again. L align here. Maybe it is aligned and I don't understand why it thinks that's aligned. Look at this. I go L. Objective is to
So I'm going to try to get set up just a quick demo of a robot base using some connections. Here, go from the tray to the base control. So what I'm working on right now is trying to make it spin. Oh,
I need.
so what I want to do is, if we want to build this rotary piece,
Yep.
I want to actually have that able to rotate. So I'm just gonna try to physically represent it.
Sure.
Let's see, anchor.
So here's what I'm gonna end up sending you, by the way. Once I'm done this. I need another cylinder. It needs to be
Slot access.
of dimensions. So that's the 600. So that one is 600 millimeters. So this will also be 600 millimeters, and this will be 600 millimeters. Okay. And then from there, throw that up. If I'm talking too much, Glavin, you can just tell me to shut up.
Doing great.
That's looking good. I think you'll be happy when we stitch it all together.
Beautiful.
It's gonna be cool.
This will be 2 centimeters wide, let's say.
What dimensions did you say? So
The total size is going to be, the outer circle is going to be 810 millimeters.
810 millimeters. Okay.
Yeah.
Okay. Then so then 810. That's for where
That goes to here.
that goes there. Is that a radius or diameter?
Diameter.
That's diameter. Okay. And that's where the base of the motor is going to go.
That's correct.
It's going to ride on top of that essentially. Or
That's the way I see it. Yeah.
cool.
So this guy needs to be.
Okay, I got you.
Make sense? And disagree if you'd like. I'm
No, I like it.
free balling.
Yeah, 800. Okay, I'm gonna make some notes in our doc. What did you say it was?
810 for the entire diameter.
810 millimeters for diameter of outer. Eight
Okay. Now I need to align
so I'm gonna have
this and this.
So I'm gonna get half. That's 405. So what I'm trying to do is make an actual interactive, interactive piece to represent this. So I'll just show you this, and we'll do resizing after. We're gonna do this. I want to make it so we have an interactive demonstration of what we want to do. So the arm is gonna have a rotor. It's gonna spin around. So let's make it actually spin. Here. Here. Okay. So we have these two are going to be connected. I'm going to have constraints. This is for physics. I'll talk more about this later when Lucas is ready. But so the objective here is to say, okay, going from the tray, it's going to go to the rotary arm, and they're going to spin. Let's see, physics mode. That's spinning. Okay, so we're going to go back here and say, okay, is this the right way? Yeah. So this is starting to spin at least a little better. This UI still needs to be kind of cleaned up, but you get it. Perfect. Okay, so that's good. See how I'm spinning here? I'm pressing down the arrow key. So actually, let me turn on my key. Yes. So then you can actually see what I'm clicking. So I'm holding this, and the arm is spinning. Sure. This is a little bit challenging based on the interface right now, but just to show you, you can see how it spins a little bit with it. I'm going to take this and mount them together. So another constraint, I will just we're going to have this rotary arm is going to be connected to the arm base. This is going to go up for now, just until we change it. This is also up. Change this to be very heavy. It's going to change the physical properties. I'm going to give it like a math of 1,000 there. That physics. So now that snaps. But you see the base is heavy. I made it 1,000 mass, so it's going to keep everything together.
You may want to speak up just a touch, just to be sure.
Let me describe more of what I'm doing. How's it going at your level? Good. Your stuff might be more interesting.
I don't really have much to say about it at the moment.
Well, then I will continue to talk. Okay, so yeah, so we have what Lucas is building. He's actually doing the CAD for what it's going to be for the serving tray. The arm, we want to have a little rotary base, and we want this piece here. So this blue represents the actual base, the base of the
arm. And what I want to be able to do is actually have it spin. So if I do this, see that up, it actually spins a little bit. So we're going to get this piece, which is the base, and move it. Okay, so see how it spins freely? So that's getting there. I also want this control to be something else. So I'm going to make this left. So if I go up, arrow, currently it spins like this. If I go left, this spins.
It's 20 thick. That's 24.
So what I want to do is move it out a little bit. This. Cool.
So I raise that.
And I don't necessarily need this to be so high up. That's probably fine. Again, the interface I want to improve in the future, but it's a good place to start. It's a little bigger. The rotary arm is a little small right now. Make this bigger. So this is what the rotary arm here is. What's actually going to be mounted to hold up the actual arm and everything. So this is what's spinning. This UI is going to be improved in the future, but the general idea is we're trying to say this arm is going to spin, which represents.
I unfortunately think I have to make this a bit bigger. 25. Can you scale easily?
Yeah.
825 for the outer.
Yeah. So you can see here, now we have an arm. Take a look, we got two far.
Unreal. That's looking great.
Yeah, and then this axis is wrong, but I can change this in a second.
Oh.
So then I think here, boom. So now I can spin this, and I can spin this.
Unreal.
So this will be the arm. So if you need to move around. And when we have your model, we can just swap in it.
That's going to be sweet.
Yeah. I can show some other demos, actually, while we're chilling.
I hope what I'm trying to accomplish is making sense to anybody that's watching. Basically, you see on Glavin's screen that he's trying to build a rotating model. We're gonna fill it in with what we picture to be the actual base. Hopefully, as long as our ideas sort of make sense as we keep moving forward. But it's just a starting point for now.
Yeah, I'm gonna change this a little bit actually, because yeah, I'm gonna change this a little bit, but that's exactly it. So we'll have the rotating piece. So the arm can be at any side, but the focal point is the center. So the Jenga is gonna be inside of here. And actually, just to make it a little more realistic, let's go to Sketchfab. Do we have Jenga?
Oh yeah.
Download a Jenga model, and that way we're not thinking about what it should look like. We just have it. So let's see. All of these actually are fantastic. Like, these people are incredible. This is one falling. I'm gonna pick the falling one just to represent better what we want.
There. What do you think? I think my model's complete.
Hold up right there.
Yep.
Oh wow, this is a big detailed one. Jeez.
Unreal.
All right, so I'm gonna import this. Okay, give me a second. So I got a broken Jenga model, and I'm going to go in here. We're gonna stop physics, upload broken Jenga. All right, small. So we're gonna go. Here.
How do I save? I'm assuming it just saves. I've assumed that before. I assumed that Yu-Gi-Oh! Forbidden Memories auto-saved, and no, that wasn't it. It was Crash Bash. We were playing Crash Bash.
Crash Bash didn't autosave.
It didn't auto-save, and we had to restart.
Jeez.
Oh, it was brutal.
So that's what we want to achieve, ish. But notice it spins. So I'm actually not going to do that. Just change a couple things. So I want to make sure the controls. We'll do we'll do this bottom one is left and reverse is right. And we'll do this piece here. I think I'm going to do them as numbers because then you can actually control them a little better. Eventually, this will all be with software. So I can go left, right, right,
Oh, very cool.
and you have numbers to spin this guy.
Very cool.
You liking this?
Yeah.
So what I have some fixes already in mind, but what's going to happen is we'll actually have the dish. We'll have your dish. I'll be able to put this on top of it, and we can actually circulate around it and build the arm.
So that cube is a representation of the
base.
connection point of the outer ring.
Yeah.
Is that the idea?
Yeah, so
Oh no, that's the base of
that's the base of the blue is the base of the arm so far.
So then that post is the connection point to the rotor.
It would be under there. Yeah.
Yeah. So here's my model. This should be able to flow freely when you replace your or mount it to it. I guess is what you're gonna do. Yeah. Physically, you're gonna mount it to
mount it. Yeah.
Although you're going to have to modify yours a little bit.
That's okay.
Anyway, I'll send you this.
The big problem I'm dealing with right now is so the physics, everything in the physics is all boxes. So I have to make sure that they just don't.
Oh, your only modification. May I give you some advice or what I'm thinking? That's perfect. What you'll have to do is put the beam underneath with attachment points that come up higher, so that this connects to the circle because it's not supposed to move, and this connects to the rotating arm.
Yeah, that sounds good. The problem I'm having right now is I can't put something on top of this because it's going to touch the beam. What I'm going to do is I'm going to make the beam smaller. Yeah. So this beam here, I'm going to make it smaller and then move it out. Actually, I'll just show you what I mean. So like I'm going to make this smaller, which you might think, oh great, well now it's not the right size. But if I go to the physics piece, which is the tray to the arm, I can now move it outwards. So then it doesn't collide. And then I can do, maybe not that part out, but maybe this, and then make it a little bit longer. Actually, not even that long. That's actually fine. If I go back to here, we can take this guy and then bring it in. So now I can go back to, I'll just restart the physics. So now here, bloody hell, sorry.
It still needs to rotate.
But you see what I mean. I'm rotoring in the wrong place, but
yeah. Can you change the relative?
Yeah, I gotta think about it for a sec. I've never done all these things in my own app, so I gotta figure out how I did it.
Interesting.
Yeah, I want the center point of the constraint to be here.
Do you have a frictionless object yet? Because if you can couple them with a frictionless object, then you can have the center. Then you can have that rotating. Because if you put that beam underneath the circle, as I understand it right now, if you put that beam underneath the circle will spin too, and that's a problem. But if you had a way to do a frictionless join, then the join would assume that it'd be like having a bearing. Yeah. So then the circle wouldn't rotate. Does that make sense? I take it you don't have that feature.
I think actually I just did this wrong. One sec. What I want, 1 second. I can actually just do what I was trying to. I added it to the wrong spot. I meant to do this.
Oh, how'd you do that?
I pushed it out. So there's two different points, right? There's a pivot point that I want to exist in the center of this object, and there's another pivot point which is how it connects to here. So I moved this pivot point outwards, so they weren't overlapping effectively, and then I kept this pivot point there so that when it spins, it does the same. So now this is fine. So now what I could do.
Yeah, you'll still have to put it outside the circle. Though.
Yeah, well that's fine. But at least now I can put like a mount in the middle of this, and that mount won't collide with stuff.
Gotcha. Cool.
And then we could put your base on top.
Cool. Let's do it right now. Yeah. Or I'll send you this now. Robot arm
base.
Cool.
I've never actually used this too extensively, so I'm like learning as I go how to use that stuff.
That's hilarious, but great. Okay, so my drive, GLBs, and I'm gonna put robot arm base in there.
Does anyone in the chat have questions or anything like that, or I think this is neat, cool, anything?
Okay, good. Go take a look at my base if you'd like.
You uploaded it to our drive.
Yeah, I'm going to put Glavin's screen as our priority here because I want to see him integrate. I'm very excited to see how easy this is.
Oh, I'm going to pumped. This is going to be very new to me. I'm just hoping it all works. All right, so we have a robot arm base. We're going to download that. We just put this in our folder. Second. Okay. So if we go back into our app, we're going to stop physics. None of that. We're going to go upload model, robot arm base. That's what you created. Yeah. Boom. Give it a sec.
It's probably there somewhere.
Yeah, I think it's either too small or too big.
The scale it's 600 millimeters on my screen.
I think the problem is mine is all in, I think, meters.
Oh yeah.
Mine is all overscaled.
So you just scale by 10.
That's what. Yeah. If I do this.
But scale mine by 10. That's fine.
Wait a second. Nope. Yours is big. That's okay.
The size matters. Try and maintain the relative size.
It's proportionate.
To itself. Yeah.
I'm gonna have to go back and kind of like fix some things up. But I just wanna show what it would look like, and then we'll go back and put the sizing in.
Okay.
Because I have to fix the rest of these guys too.
Okay. All right. So while you're doing that, I'm actually gonna start building the base for the arm that will mount to this circle.
Yeah. So here, one sec. So what did you have in mind for this piece? So this is what goes.
So the centerpiece with the ring is the stationary piece. So that's two pieces.
Oh, and this outside ring rotates?
Yes.
You give them to be separate pieces?
Yes, I can do that.
Yeah, then I can do some neat stuff. Wait, why is there an outside ring that needs to rotate?
That's what the arm's going to be on.
The arms. I was just gonna do that.
But we're talking about what's going to happen in real life.
Yeah. Well, that's what I mean too, right? Like we don't need, like if an arm is just gonna be on one point of this, won't it be?
That's correct.
Is there advantage of having all the other?
Yes, absolutely. Because what we're going to be doing is we're going to have a stationary motor, and that stationary motor is going to be coupled with that entire ring. So the ring moves, but the motor doesn't move. There's no other. There's two ways we could do this. If we're doing what you're suggesting, we'd have to have an arm, have a motor connected in the center.
Oh, I see. Yeah. Okay.
The easier way, from my perspective, because then we don't have to worry about flexure forces.
Yeah.
The easier way is to put a motor here and spin an entire ring around the motor.
So the ring is like a lazy Susan.
Correct.
And you're just like kind of driving it.
Correct.
Cool. I like that. Yeah,
Cool.
we could do that.
It's like it'd be like I put the motor here and this desk moves around my finger.
Because then it's actually we can put wheels under it effectively, like to make it have contact and there's no torsion or whatever it's called. Yeah.
Yeah. We could have a few different points of contact with wheels. That'd be great. Yeah.
Perfect. I like that a lot better. Okay, good. Yeah, if you make them separate, I can make them interactive.
Cool. Yeah. That makes sense though. So obviously you had a different idea. You were envisioning this, but how would you? So what were you thinking?
Mine would have the same problem that you described, which is you have now an arm under the arm. Like now this thing is going to have to take a lot of weight on.
Yeah.
I like your idea because we can have disperse the weight. Yeah, we could disperse the weight, so it will be like a lot bigger than this. And then we'll have the arm on this outer edge, but this outer edge is spinning. Yeah. That makes sense.
Okay.
If you send it to me, I can legit. This is gonna be cool.
Cool.
I think you're gonna like this.
Sick. Let's do it. That's what I was picturing right out of the gate. I didn't realize you had a different idea.
No, that's perfect. That's great. That's why I like the visual stuff. Because then we can just let's see how it plays out.
Yeah. Okay. So let's call this, and that's where I was getting into the rotor stator comments, because like a motor, you have a rotating circle and a stationary circle.
Yeah. That makes good sense.
I'm showing folder. This one is the rotor arm base.
Yeah. So I just need them as separate pieces.
Working on it. Show more options. Rename. This will be robot arm base. And this will be the rotor. And this. Can't you separate GLBs?
I can. My software can't.
Okay.
So eventually, what I'd like to be able to do. So like, there's sometimes when people will upload an object like STL, GLB, whatever, and it has like a collection, a full stencil. I would like to be able to go in and be able to say this thing is actually separate, and we can extract it. 100% doable. I just don't have the feature.
Okay.
Yeah. So
good.
The future is you just upload all your files and you can edit them and break it apart, at least in here. Like edit it, add physics, make it reusable.
Perfect.
Yeah, but not yet.
I assume that's why I sent you the whole thing. I assumed you could.
I can later, but I want to use the non-coding option.
Cool.
Everything is the editor that people could use today.
Cool. So I'm gonna get rid of a robot arm base. You can delete it out of there.
Yeah, no problem.
And I will. And I'm going downloads and robot arm base, robot. Oh, sorry, robot arm rotor and robot arm stator. Okay, they're in there.
Sure. Perfect. All right. Thank you.
You're welcome.
That piece. I'm gonna upload separate pieces. This. I think the size and wide was. We'll fix the scaling later. I just need to. Now we've. This is the outside ring. Excellent. Oh shit. Stay there. Don't touch anything. Okay. Upload another model. And.
So you have the rotor already.
I have the rotor. I need the stationary piece.
Yeah.
All right. Now this is the match thing. Stop doing that.
Why? Oh shoot! I didn't give you enough of it.
The edge.
Yeah.
I'll build it with this, so you can swap out the model after. So
Yeah.
you do you stuff, and I'll get this up.
Yeah. I missed a piece. That's my bad.
Okay. So what I want is this piece here.
Yeah. So in Tinkercad, to make an object a single object, you have to actually do a combine function, and I
Yeah.
didn't do the combine. But
No, that's okay. That's interesting. What do I want to do here?
So can I explain what I was thinking before we were aligned? Using what you have, if you were to put that beam that moves underneath your stationary circle, actually, you don't even really need the stationary circle anymore. Just put mine in place of it.
I'm realizing I'm gonna have a problem with the physics because I don't have holes, so the physics is gonna touch and they're not frictionless.
You don't have holes. What do you mean?
So this part here, I do not have a way. You know how I did this piece? Like I moved it away from the center, so there's space here. It's like kind of like a base. This actually looks like this. See, it's this piece is actually like a full box in the physics. So what's going to happen is
So rotate it. I want to see how the box moves.
Yeah.
Uh,
Right, it's a bounding box.
Oh, the center isn't removable.
Right. So the center, like at least not yet. I am working like that's something I've worked on this week was the center removal, but I don't have it working
For now, could you remove physics from a single object? Because if so, you could just remove the physics altogether of the other object, and then is that possible? That won't work.
Oh, maybe I can actually.
That's probably too quick a cheat, because then the Jenga blocks will fall through it if we actually use those.
I have another idea.
Okay.
Because I can make things hover. So like I can make, yeah, that should work. So I'll make this. I'll make this on top of this physically, like the bounding boxes don't overlap, but I'll force it to be above the ground. Yeah, I'll show you.
Okay.
I'll show you. I have an idea.
I don't quite understand, but that's okay.
What I want to make sure is they don't touch. I just want to make sure the bounding boxes don't touch.
Yeah.
Because in the physics will freak out. So what I need to do is force them to be separate. How do I force them to be separate when they're not touching? I think I can make a constraint that it's like, here's the base that's on the ground, and then here's like an invisible force field between it, and then here's the other piece. It's a plate, and then okay. So I'll let me just tinker with it, and all this will be cleaned up once we have more realistic physics. But for now, it is as it is. So I want this. This is going to rotate around this piece.
Yeah. Before you get too far, you can take my design if you'd like, just so that it's the proper one.
Yeah.
Later. Replace existing. Boom. Stator has been replaced. Hey, Lorian. Good to have you.
So what I'm trying to do here is I want so the same thing we have the arm. If I go in physics mode, I can rotate. Oh, jeez, what's going on here?
It looks like you didn't quite position it
I think
properly.
I probably mounted it to the wrong thing. All right, but you get the idea. So we want it to spin. I don't want it to spin with this, so this can go away. Give me a second. So if I have this is the previous arm, which is just a box that's extruded out. I'm going to replace it. So it's centered here up a little bit. So I'm gonna remove some things. Maybe I'll just start from scratch actually.
Yeah, use the new stator.
Yeah.
Since you have it.
Yeah, give me a sec. Okay. I'm gonna start deleting some stuff.
Okay, I'm gonna get you. I'm gonna make a mount for the
this to connect to that piece. I can control with an up arrow. That's fine. So if I'm doing up, okay, good. So that's why this is actually the wrong axis. This stuff is going to be unfortunately a little complicated until I make the interface nicer. So what we want is if I press the up arrow, this outside ring spins. That's it. That's the simplest point. So right now we have this connected to the tray. So that's that middle circle. And we have this outside piece. I'm going to rename this arm base rotor. Okay. Connect arm base rotor. Yeah, that sounds good. And then see how it like turns in a weird way? So obviously it's not set up properly. I think this needs to be a little higher. So now it's spinning. It's spinning in a like weird way though. So,
It's like your pivot point's in the wrong spot.
yeah.
Yeah, it centers. It doesn't
Um,
where its center is.
I don't know that. I think it's visually.
Yeah. Well, you're
Let's fix
tinkering
that.
with that.
Yeah, I'll fix that. But I think it's something else. Something with the way it's exported. I think it doesn't seem. I still have to do some checks to make it clean up models that are. It's gonna be interesting to figure out. But you see how it spins. So at least we're there. Actually, I'm gonna just keep going, and I'll come back and fix it up. So we're gonna put the other piece. I'll just put the box again. This blue box is again gonna represent the arm. And this is all you were thinking, right, Lucas? Is just to put the arm right on top of.
Yeah, that's right.
Perfect. Okay, so now I'll actually just flat out do that. And so you got this. Boom. So we're going to create a constraint. I'm actually going to make it a hinge because I can rotate it. Like it'll actually, I think it'd be cool if we can rotate it around and then also have it face in different ways. So like it's kind of like, I'll just show you. So
Oh, for sure. Yeah, it has to reorient itself.
yeah,
Absolutely.
so we got the rotor. We got the actual box. I need to rename box. Box is not a good name. This is the arm face. Need this now. Yeah, that's spinning. Okay.
Shape should I make?
All right, cool. So I got this. It's off center, but that's I think an issue that I need to correct some of the numbers.
I'm very interested. Go to your numbers. I'm curious.
I think the issue is that the model exported. So like this is right now. If you look at this from a heads-up view,
Yeah, it's not centered.
it's not centered. That's a model issue.
How is that a model? How?
So like the model itself can dictate where center is.
But how do I fix that?
I'm not really sure. I wonder. So when you did the export of an individual piece, can you show what that looks like?
Yeah.
Yeah.
I've had to fix this in a like this is not just yours. There's a bunch of them that I have to fix this with. So I want to build a tool for later that can like auto fix it.
Yeah, so that's it.
Yeah. So you see this.
That's my center right there.
That's your center right there around this.
Do you want me to try
Can
and
you go?
export
Can
it
you
again?
go back to that menu you just saw? Let's see what else. Oh, I see. Okay. Well, right. I'm screen share your screen since we're looking here. So what we're trying to figure out is why the model that's exported, the center of that model is slightly off, and I've seen this in a lot of different things, but it's just tricky to solve. Like maybe is this like see how this is bigger than that?
Sure.
Like I don't know.
I think it needs to be centered against this.
That shouldn't like it doesn't make sense, but there's something wrong with it that.
Um, center object
Yeah.
0 to 0. Finger tap.
What I can do is I'll just keep tweaking this for now, but
Sure.
because I do have an offset thing exactly for this problem. Like, this is far from the first time I've seen it, but it's not very good to use, unfortunately. Where center?
How to put it in a certain location.
Our goal is at like the visual center of this. This dot should actually line up with that dot.
I should be able to make it. I should be able to center it here, and hopefully that fixes your problem. So let's try that. And I'll understand that I have to be a little bit more careful about where I put things.
Assuming that's it, like that's the thing. It's like it's
Well, we'll try it. Yeah. So challenging. Tinkercad is great for a lot of things, but awful for others. Like it's very hard to
I'm
make
getting a little better
discrete
because of this.
locations.
Slightly better.
How'd you fix it?
I'm just manually tweaking it. So I got like I've been having this problem before, so I built a way to do it. I just have to like keep trying a bunch of different magic numbers.
I would much rather be able to figure it out on my end.
That would be the ideal. While you're doing that, let me try to fix this base. Let's try.
Move it this
So this is the wait. Let's try to. This is going to be heavy base. This is what's going to mount everything on. Base. I'm going to change it to be a little different.
It's half of 175. Quick maths.
175 half. 0.875.
Wait. 87.5.
Base, which just rotates around, and this one's going to come down a bit. Base is a little bigger.
Okay, that should theoretically be centered. Okay, I'm gonna export this again. I'd like you to try it just because I want to see if it works. Export GLTF. This is shown folder. This will be the rotor. So let's delete that.
I want to mount this the tray on top of it. Okay.
Okay, GLBs.
There we go. So now this kind of works. So I have this on top. This is stationary.
Yeah.
This I think is stationary. And this is rotating.
Cool.
So now I can change some things to make it a little closer. But you get the idea.
Yeah, try mine, see if it centered itself. Now that I've centered it in my
Do you? It's uploaded to Drive.
Yep.
Okay. Is it the rotor part?
Yep.
Everyone in the chat's doing all right. Finding this interesting. It's definitely an interesting exercise for us.
Yeah, this is a little more challenging than the car was.
Good. Okay.
I mean, we already came up with a cool solution for the base. That was a good
Centered.
It's a good success.
Edit physics. There you go. Upload. Do the centered one. And that just needs to be adjusted.
Yeah, I'm gonna put it on. I'm watching Glavin's screen, so I'll get you guys to watch Glavin's screen as well.
I gotta figure out what that is. It keeps.
I saw that. Yeah.
Is it more centered? So.
Yeah.
Should this this needs to be centered there. So what I can actually do, all these models are just URLs. So I can just go copy this, and I can replace.
It's a nice feature.
This one. Which I don't have to get rid of. But see how it moved over like that? So clearly there was a difference.
Yep.
And I can now get rid of the offsets, which I manually added in there. And it seems to line itself back up. Okay. Let's get rid of this new guy that I don't need because I already have it. Okay. Go back to physics.
Perfect.
Beautiful. Absolutely perfect. All right.
You should put the right rotor in.
Yeah.
Get rid of those junky pieces that you have off the side. Clean up your workspace.
Right here. Okay. Gone. Did you get me a new one?
I did, yeah.
Okay. It has the lips and everything.
Yeah.
Sweet. Right, so now what we're going to do is get the final piece, which has the, like, essentially the lips on the side. That's going to keep all the pieces from the Jenga blocks in. Yeah, I'm just going to make this. I think it's like rounding it.
Hmm.
Note this piece here is currently a cylinder, but if I change it now, fingers crossed this doesn't crash anything. All right, pray for me, everyone. Change it to a model. Right, I go to this, and I'm going to copy the model here, and I'm going to go back to the tray object, which is now boom, and
I think that was a fail.
give me a sec. Give me a sec. That's fine. We'll just undo some things. Okay, well that's easy enough. We can just take a look at here and say what relationships we have. Well, all we really want to do is just make sure it's mounted. So I'm going to take this, move it over here, take this, move it over to the center, and this is going to be interesting because everything's currently shaped as a box. So the spinning is going to like, but we'll figure it out. I think we're making a good list of features we have to add, which is nice. Yeah. So just for an explanation of what I just said, you see these red boxes around everything. Like this right here, that's the physics representation of it. So as this spins, it's gonna hit this edge. So it's not gonna work. But we will at least see something.
Oh, because what? Sorry.
Because my physics is just using bounding boxes. So this thing is round. We shouldn't hit it because it's round. It's actually square in the physics.
Mm.
Yeah. Which I'm working on. Like I was working on that problem this week, and I have a solution for it. It's just not ready. But in the future, what will happen is you'll be able to upload something, even something like something as complex as this, where it's rounded and it has like a cutout in the middle, and then it'll automatically be able to convert that to something that's more accurate for representation. So, work in progress. What do I want? Move this way. So this right now has a lock constraint, and all it is just saying, I'm going to mount the tray onto the base. So I'm going to remove all this and remove this, and we're going to do the same thing here. So I'm going to say lock constraint, cool. I'm going to go from the heavy base, and I'm going to connect it to this one, which I'm going to call the tray. Okay. Yeah. Okay. There's troubles here, but what is the problem? So this probably needs to go out a little bit more. Oh, shoot. Okay. All right. Well, at least it's working as expected. So let me change a couple of things. So ignore a couple factors here, but I think we are getting closer. So I'm going to go back to this. This doesn't need to be so high up. I'm going to go here. Let's get rid of the physics representation. So this piece here is rotating. Doesn't need to be one. We can make it one, a little bit hovering. Still rotates. That's great. This piece, same deal. Doesn't need to be that high. Notice, so see this box, if I go to here, it's far enough away, so it doesn't hit the edge. But it is actually still too far, so we don't actually need to be that far out. I can go out here and it can still just narrowly. You can see how this box here is not colliding. So that means physics isn't going to hit, which means I can do this. Boom, boom.
Beautiful.
So we can put it all together now. I can take this and this and this and this, and we can rotate it. Ignore the fact that the blue base is so far out. That's just because the boxes, like this part, is too boxy. That'll be fixed. But you get the idea. So now it's rotating around. This is what we can actually build. And yeah, we have it rotating, and we'll be able to put an arm on top of here.
That's pretty good. It's pretty good. I don't think your thing's centered, but it's pretty good.
No, it's probably not. I think I have all that.
Yeah, it's fine.
What else do I have? I wonder if I have an example. Dude. We'll see. This is not what we will have, but it is just a cool representation, and I will make it bigger.
I want it like this. I feel like that's a good support size. I'm gonna add another. I'm gonna add maybe a triangle.
See, just to visually represent what we're doing here. This guy here, and that's actually can just replace the blue. Blue box, but not just a blue box, and then we're gonna put this guy nearby. This is effectively what it's going to look like. This robot arm. We're looking in. We have a rotor to the new robotic arm. See, it goes right to the middle, so that's not quite right yet. We want to actually go up a little bit and a bit. That's it. This. We get spin, so we're gonna do this. Like,
There. That's what I want for the mount. Something like that. Something off the back. Ah, nobody's watching me. Right. 2 screens. Yeah, this is what I want. So nice. We have a rotating piece, and then our arm is going to have a bit more area.
Yeah, more
off the end.
supported. Yeah, that sounds good.
yeah, let me see here.
So with that, but
There we go. Okay. Don't need to be so high. Yeah. Physics. Cool. So this is it. And I'm gonna make it a little lower too. There, so like this.
oh, where'd you get that? Grab pad?
I just found the model. Yeah. I'm gonna move it out a little bit. It's still too big. So you see how it collides on that edge. So we're just gonna take this guy and move it out a bit more. Up now. Right, pretend it didn't clip, so it won't be so far out, but you get the idea. We can go in here. I'm gonna add support to go a little bit reverse as well. We can kind of look over here, look around at it. See,
That's very cool.
we can go to any side and actually inspect this.
So for a piece to be movable, because like obviously your supporting piece is moving in your case. For a piece to be movable, I have to give you 2 separate objects that you kind of link together.
Yeah,
Okay.
yeah. If anything that's one will be treated as one.
Okay.
Yeah. In the future, I'll be able to have it so you can have an upload, and then I can say actually, like only select this piece of it, but that's not ready yet.
Okay.
And that's pretty much the gist of it. Now, all right, do you see this too, Lucas? You should be able to pull up this link if I send it to you.
I'm in it.
I've been backing up checkpoints.
Oh,
So
okay.
you're gonna
Cool.
see. Let me just send you a new one. Yeah, and then you're able to go and play around and make edits. The cool thing is, yeah, if I send this to you, then you can play around with the physics while I make edits to it, and you can see it live. So this is the latest. I'll add it to our document. Yeah, there it is. Oh, nice. Your base looks great. Yeah, so if you want to take a look at that link, put it on your side just to see that.
Yeah.
To show that you can do it in real time as well.
Yeah. Yeah. How do I actually interact with it?
Play button at the top.
I see what you mean with the hovering. Yeah. You can really get her going.
Yeah, and we can also tweak the motor. So one sec. So while you're doing that, I can go in here and go in relationships, and let's make it a little more realistic. So from the heavy base is going to rotate the rotor. So we're going to make this a little bit slower. I'll make it 5. Half the speed.
Yeah.
But I can even go slower than that.
Oh yeah.
So this is me editing live. I can crank that up. So this is me tweaking physics properties for the motor. Boom. I'm just gonna.
It's very cool.
And yeah, so ideally we're able to see like how fast we want it and how much forces those are, and even a lot of these constraints as well. We can put on braking forces. So let's say we put too much effort and it might break something.
Mm-hmm.
Like if we built a house out of toothpicks, what would it take to actually shatter it? We could represent that.
That's very cool.
Yeah.
Very neat. Very cool.
Yeah. Any questions from our chat? Saying hi from softball. Hey, I think that was a little while ago now, but thanks for tuning in.
I'm certain she's back in the game now.
That's great to be able to join.
Uh,
Cool. Yeah, if you send me that, I can pull it in. What do you think are next steps? I'd love to do a little bit of diagramming in the schematics.
right now?
Yeah, if you want to.
Sure. Yeah, I'll
Since
send you
I built that thing ready for us to do it.
Yeah, let's do it. But do we actually know what we're trying to accomplish?
You said you had an idea in your mind.
Yeah.
Put it out on paper.
Okay, let's go with. Let's get it all. Save this. Export. Shall be. Show folder. We got our base.
For all those in the chat, I think we have 3 people watching. Does anyone want to comment on what we're working on here, or how you finding things going? Any questions? Do you think this is a cool project? Any ideas of what we could do next? Anything else? Want to make sure you're all alive. Okay, maybe I'll show a couple other projects that I've built in the past and see if people find them interesting. Let's see now. Some projects I've built. I got to see which of them actually will run on this new system. Yeah, so here.
There are ear rotors in there.
This is an example of one of the courses that we have, which is the one we showed earlier. It's had light up and the colored LED. And you can see here we have a Raspberry Pi, our LED, you have a toggle switch, a resistor, battery pack, and a bus. And you can go and view these as well in their 2D format, right here. Kind of dig around. Yeah, so that's one of the projects you're able to build, and you can put all the parts together. Let me see if I found something that's I'd like to show some of the interactive pieces that I made. Let's see, which should be up to date. Bear with me. I'm going to try to find some cool ones.
Okay. Make a new project in your software. Scenes.
Okay. Oh, sorry. Great. You had something up? Yeah, we can do the schematic now if you want. So let's,
Yeah, let's do.
let it load. Okay.
Yeah, let's do it. Do you want to just put your screen on and
Yeah, sure.
actually, or if you send me your link as well, then I could edit it with you.
Sounds good. Scenes. Should I just update that latest? Yeah.
That's a different one. No, I'll rename latest because that's like the latest 3D.
Sandbox. All right. So now let's try. So we're the way I see it, we're initially designing a hand, and the hand is going to have. Well, we kind of have to come up with the hand that we want first. So let's see. Grabbers. Robotic arm. Grabbers. Okay. So
Those are cool.
Yeah, I would like something maybe that's aligned with something like this one. Not quite, but more like this. So the reason I want this type of grabber is because it has, these straight pieces that have a grabbing mechanism. So it grabs with pure compression instead of a closing mechanism. It's compression between two straight plates. The reason I want that is if we ever want to actually have the robot push blocks out as if it were playing Jenga, we need that straight piece as well as the ability to pick something up, which would be the compression. And that versus something like this where it sort of, lack of a better term, scoops it or closes on it.
Mm-hmm.
What are your thoughts?
Yeah, I like those kind of pieces. It looks good, especially if you think with the shape that we're trying to grab as well, because it's going to be little rectangles.
Mm-hmm.
Yeah, I think that would work nicely.
So I'm thinking if we made this metal piece the width of a block, so that wide, and then your arm. Let's say your arm typically sits like this. When you're going to push one out, what you'll do is you'll rotate the arm this way, lift this up, and push. So push it out, and then you go to the other side, grab, pull, lift.
Yeah, like poke it through, grab the other side.
Yeah. So for the poking function, I'm thinking we want the arm, the claw to be as big as possible, so it has the most gripping area. So I'm thinking our limiting factor is the width of a block, so that we can actually make a hole in the Jenga tower.
Mm-hmm.
If that makes sense.
Yeah, we wouldn't want it to be too big because then we can't poke through.
That's right. So we make it just slightly smaller than the width of a typical Jenga block, so that when it centers itself amongst the Jenga block, it can push and not come in contact with another one.
So the fingertip's smaller. Yeah, you can push.
Yeah.
Okay. Yeah.
If that makes good sense.
Mm-hmm.
Yeah, and I'm thinking we'll have the head of it will be able to rotate 90 degrees. Now, we will come to that. That'll have to be a bit of 3D modeling, but we will have to. What we're trying to do right now is come up with the actual mechanism to make that happen. So there's a couple of different ways you can do that. Probably the simplest way is to have a servo motor that sits in the back of the arm, and it has a string attached to the arm, so that when you pull on the string with the servo motor, it rotates, it pulls the string, which causes the finger to open. And our retract action could be a spring in the other direction. So the spring holds it closed always, and then a rope pulls it away from the spring. If that makes sense to you.
Yeah, using ropes, because that's one thing when I was doing reading about robotic arms, making sure you don't have direct motor to object pressure. You want something in between to sometimes they use a spring like you're saying, or like different ropes with different elasticity, because then it can kind of adjust if we're like making a mistake and not break something or
Yeah.
um,
Yeah, I would. Yeah, I basically, the way I see it is we have a spring that causes a closing force always.
Yeah.
So its natural state is to be closed, and we have to use a rope to pull it open.
I see. I guess my concern with that means our maximum gripping force is the force of the spring.
Right.
And I'd rather the maximum gripping force be something we can improve with the motor, but maybe the. I guess either way.
Either way, it's a spring.
Either way, because I've seen other ones where they have the gripping forces like the motor, like pulling it in some direction. But either way, they put a spring in the middle to make sure they're not again doing it directly.
Yeah,
you could break something. So
the alternative choice is to have a gearbox, which is a lot more
messy.
Yeah,
I'd like to not have gears. Okay. Yeah, that sounds good. So if you have, one sec, maybe
or at least one of the alternative choices.
Close that door. Give me a second. Yeah. Okay. Yeah, I think that could work then. So, so it's forcing close, spring it open, or we use strings to pull it open. All right, we think about the material, so it's some kind of rubber, and how much force is required to force it.
Remember, we're only lifting 10 grams.
For this case, yeah.
Well, that's our objective right now, right? Like we gotta make sure. Like we're not trying to future-proof our first robot.
Fine. All right. Just Jenga poking.
Yeah. Yeah. So what we'll do right now, and we'll probably end the stream shortly. But what I'm thinking we do right now is quite honestly just make a simple circuit that includes a servo motor.
Yeah.
So we build our servo circuit, which will include a servo, a connection to a Raspberry Pi or Arduino, whichever we decide to use, and a battery, a switch. You know, your standard framework for a basic circuit. So we're just going to be designing the connectivity for the arm itself, which from my perspective needs two. We have a choice. We have another choice. We do want both of the fingers to move freely
independently or
into
parallel.
If they're
symmetric, yeah.
If they're parallel, so we have two choices, and again, we're at another roadblock. So we have two choices. If we want to be able to play Jenga, we want to be able to open it to 90-ish degrees so that it can get out of the way.
Poke with one of the fingers.
Poke with one of the fingers. To do that, one of the ways we can do it is have two separate servos so that it can move free independently of the other. The other choice is to be able to open it so that the fingers are 90 degrees apart, and you can move the wrist enough that it can line itself up at 90 degrees. So by that I mean, for the camera, by that I mean if your normal operation is here, you would need to be able to open up your hand to 90 degrees, your fingers to 90 degrees, and then you need to be able to rotate it and push. The other option is to be able to open one out of the way, leaving one stationary, still rotate and push. But the concern, well, I guess it just doubles the force. That's it. It just doubles the required force. Only concern with doubling the required force is that'll put some strain and stretch on whatever string we have. Is that an issue? Probably not. It'll put some strain and stretch on the spring as well, because you're kind of maxing it out. Further you go, the more the object's the string or the spring are gonna take on memory, which is not a good thing. But I mean, we're still only talking about being able to pick up 10 grams, and we'll size our spring appropriately to be able to pick up like 50 grams.
Yeah. Okay.
So which would you prefer, one or two servos?
It's always nice to have less servos, but I would think the control is kind of nice to have on a per finger basis.
On a per finger basis. It's more scalable.
I think so.
Because then we could just slip in a third if we want.
Yeah.
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 Yeah, okay, so we'll do 2 separate servos. I'm trying to picture how to mount them right now, and I don't have a really good picture. They basically sit separated enough inside an enclosure that they don't come in contact with each other, but close enough that we don't have to make a huge body for it. The servo will have to pull. We'll have to sketch this out. It'll be tough to kind of visualize without a sketch, but that's okay. So what we'll build right now is a simple single line that controls one servo, and call it an evening.
Yeah.
Cool.
Yeah.
All right. Are you in my sandbox?
Yep.
What do you got in here?
Things,
toys.
just things.
Cool. So I'm gonna go in 2D mode, and can we? What do you want to use for a controller? Do we want some sort of Wi-Fi capability? If so,
I don't use a Pi.
You want to use the Pi?
Yeah, I like Pies for everything. But with the Arduino, it's really nice. Like the Pies, we could write it with Python. Makes it accessible.
Okay. So let's drop that Arduino then. Arduino Pi. Jenga block can stay. Switch can stay. Battery. I'm gonna drop that battery. I just want to use the 9-volt. I find it a nicer model.
Okay, cool.
Our clicking is still off.
Oh yeah, sorry.
That's okay. That and add a component. Components, power supply. Oh, you don't have the 9-volt in this one.
Give me a sec. I'm adding it.
Adding it permanently, or just to our model?
I'm adding it to here.
Yeah. Ooh, could not load. There it is. Nice, beautiful. Curacao.
Need this. All right, so this is where the fun stuff I think you're gonna like quite a bit. So we got 9-volt battery. Cool. I'm going to add a port, and we're gonna say we have power. And another port. And I'm just gonna go back over here so you can actually see this. See this 9-volt battery? I'm gonna change this. We have power and ground. Boom.
Where are you changing that?
So like that. All right, take a look at my screen.
Yeah.
So
it's in
so
file.
all of them. Yeah. So so first you're here. You have nothing selected. Click on the battery.
Yep. Oh, I see.
You see add port. Now you select on the right hand side. So try add port.
Oh, I don't see add port. Add?
Yeah.
Oh, add port. Oh, yeah.
Yeah, try that. Good. And if you scroll down, yeah, there we go.
So, okay. Add another port. Negative. Cool. Very nice. Okay.
I built that last night, so I'm glad it worked.
Beautiful. Okay, so yeah, we have our positive and our negative terminals. Very nice. Okay, so our initial circuit, as always, we got to power our Raspberry Pi. So powering our Raspberry Pi goes from positive side of the battery to the line side of the switch. You can see that it happens in 3D. Now, one of the things that we need to work on in the future is the ability to, when we add a model, the connection point becomes the appropriate connection point. Like, for example, the terminals on the 9-volt battery instead of dead center of the 9-volt battery.
Give me a sec. Negative. What's wrong?
Negative goes to ground.
Too high.
Left side of the switch goes to positive. And is there an easy way to change the color of those wires? Probably not.
Yeah, there is. What colors you like?
I just want the negative to be black. That's all.
Yeah. So if you go, select the object that you have, and then if you see this is again going to be cleaned up later.
Select it here.
Yeah. So click the object is connected to. I don't have a way to just like find arbitrary stuff. So you have under relationships, you have wires, go to visual.
So I want this one then.
Yeah, that's fine. And then go to visual, and then this color, and
Yeah, I should be able to change that around. Should be able to just click. I don't know why it wasn't, but yeah. Anyway, either way, and you see it's updating mine as well. Does that work for you?
Yeah, that's very cool. Yeah.
So,
Just a sec. It changes that one. That should be here. This one. Visual. Oh, I see. The battery's it's just tough to tell which lead goes. Oh no, that was just silly. I get it.
can you give me a hand actually with the lead thing? So I'm actually working on that.
Yes. What do you need?
Where would you like? So where should these be connected to? Is this correct?
The pod. I think that is correct. I mean,
Because we can move the 3D points.
9-volt battery. Yes, I think so.
We need a voltage regulator, don't we?
Oh, for the Raspberry Pi. Yeah, you're right.
Well,
Sure. What do I need right now? I need.
so we always do switch first, and then we're gonna undo the switch. We're gonna go from the switch into the Pi. Oh, the voltage regulator currently says. I'll just make a new.
So yours is actually wired backward. Do you want to just, if you could rotate the model 180 degrees, the battery itself?
These are backwards.
Yeah,
I'll just move it. That's fine.
Yeah.
The voltage regulator currently is one that accepts 12 volts, but just ignore that for now.
That's fine.
Now we're actually getting from the voltage regulator out to ground. So what we just changed here, if you notice before we had a battery connected to the switch, that's all fine. But then essentially the battery went directly into the Raspberry Pi through the switch. But that means the switch, which is meant the Raspberry Pi, which is meant to receive 5 volts, is actually receiving the full 9 volts. So we want to go through a voltage regulator. In this case, we only have a 12 volt voltage regulator in the system. We'll just put that in for now, but it will look very similar. And that makes sure the 9 volts gets down to the 5 as the output before it goes into the Raspberry Pi.
Yeah.
Anything else to add?
Absolutely. No, that's good. And as far as to be honest, we don't even have to change the model. We just have to change. We just have to have the ability to say 9-volt, which just like if voltage regulator is considered a standard object in our software, we don't have to change the model. The model, I drew it myself. It's not really a true model. So that just if you pick a 9-volt voltage regulator, all that it should change is the 12-volt terminal should just change to 9 as a default. And now I know we could do that personally, but I would like to have the option as the person selecting the component to have the selection do it properly.
Can you give me a hint? So from the Pi to the battery.
Yep.
Why is the Pi going to the battery? Pi should go to the battery.
The Pi shouldn't go to the battery. What do you have here? You have battery connected to line side of the switch. Load side of the switch goes to 12-volt. Ground goes from the battery to the voltage regulator.
Move this around a little bit.
No, everything's right.
I'm sorry. It looked like the Pi, but it wasn't. It was actually the VREG. Okay. So VREG goes to the VREG goes to the battery. Why is it still? Why aren't these connecting to the battery directly? That's so weird.
I don't think they are.
What is this? You see this one right here?
Or is that something broken on? Yeah, you see it too. So you see battery to VREG?
To VREG, yeah.
What?
That's correct.
Oh, that. Why?
That's what you just did that.
Yeah, why am I doing that?
Because you need to make your.
Oh, that's
battery.
for negative. That's the.
Hmm?
Yeah, sorry, it's the negative wire.
Do you want the negative to be black or red?
Black.
Cool. That's what was messing me out. I noticed. So I want to go from VREG to battery with a black wire. That's more accurate.
Battery to VREG. VREG's negative isn't going to the pi.
The position. Yeah, VREG only had one.
Huh?
I need to change the 3D position to the VREG right now, I think.
I don't know what you mean it only has one.
What do you mean the VREG isn't going to pi?
The negative of the VREG isn't going to the pi. This connection.
Isn't it? It's right there.
Where?
Oh, in the 3D, I don't know. I gotta take a look at 3D and see what's up. But is the 2D at least correct?
The 2D is correct, yeah.
No.
It says there's two. They're just lined up with each other, I guess.
Yeah. Yeah. Leave that for now. I will. And then the battery over there. Battery ports.
I wonder why the second wire isn't showing up. It's weird.
I think I might have added.
It says there's two. Anyway.
Oh wait. Sorry. Where's it say this to?
Well, if I click on the voltage, if I click on the Raspberry Pi, there are two wires.
Oh yeah, zoom in. There's definitely two wires there. They're just going from his spot.
Oh, is there? I don't see them.
Oh, mine. Just look at mine.
Yeah.
I think there's something up with the wire rendering, but either way, it's going to the same spot on the
In there.
on here, so like it still doesn't look correct either way.
Okay. Cool. Just leave that like that. That's fine. That's fine. We're doing the 2D model anyway.
Yeah.
So now we need to. So we have basically our control circuit to the Raspberry Pi, or our power circuit to the Raspberry Pi. So now we need a control circuit from the Raspberry Pi to a servo motor. So we'll have to find a servo motor model. And what's the website for models?
Sketchfab.
Sketchfab. Did you sign up with
Our behind the scenes
email?
logged in. Okay.
What's our username? Oh,
Just use Google Sign In. I'm pretty sure.
Gotcha. Purchase or download. Seems I'm. Okay, and I'm searching for a voltage or sorry, a servo motor.
Like we have the. Oh, that's not a servo though.
How do you get ones that aren't paid?
One sec. I might have some already.
Are some of them just not paid? And that's
Yeah, that's correct. That's correct.
servo. Yeah, how do I sort by the freest lower price? Can I just get rid
So
of
I have some steppers that might work.
steppers will work, yep. Okay. Oh, there I go. That's $10. Are there free things? I haven't seen anything free.
Top free stuff. It just might not be for this type though. That's the problem.
No, sure, but like I haven't seen anything free yet, so it must be a filter.
I'd go. Why is your thing so different? What is this? Your I don't know. Yours doesn't look like mine. So go to Sketchpad, and then I go Servo. Just hit downloadable. Like, you can see how mine's different, and I have free stuff all over the place.
Okay, so I'm back at servo.
So just go to Sketchpad. Yeah, there, and hit downloadable as well.
Yeah,
But I've also added one that I found a while back. Here.
Oh, here's one. Oh, you did add one?
Yeah,
Oh, that's a
and,
stepper. Yeah.
Is that sufficient?
Maybe not.
I was looking for motors like this a while back. This is the best I could find.
There's the servo right here. Maybe the gears. Download.
So we want to get GLB. No, GLB at the bottom. Yeah.
Okay.
Cool.
Show folder. I'll grab it and I'll pull it into.
You can upload it.
I still put it here just to have it.
Yeah. But you should practice uploading as well.
Okay.
Cool. Sandbox. Nope.
Okay.
So I can delete this other one.
Yes, please. Now I will add ports to do add port. I don't know what the ports are. Servo. So there's only 3 connections. There's signal, power, and ground. Signal, positive, and negative. Let's do that. Signal. Port 1 is going to be signal. Okay. Add a port. Positive. And add a port. Negative. Okay. Now let's go into our. So we have. 5-volt output from the Raspberry Pi. Servo positive goes to, let's go to power 5V. Where are you? 5V power 2. And negative is going to go to ground, which is 6. And then we're going to grab our servo connection, which is going to be a PWM connection. And that's going to go to GPIO 12 for PWM 0. Alright, done. Excellent.
Versus our.
It's very nice. Very, very nice.
Good.
Servo. Yeah, let's go back. I want to click servo. You fixing up the ports on the model? Is that what you're doing?
Yeah, we're gonna.
So positive. So you see the three wires that are coming out the butt of it. So the red one, the center one, is positive. The brown one is negative, and the orange one is signal.
Oh. My wires aren't fitting. Oh no, I see. Okay, I see what you mean.
Oh yeah, these are the ones that came with the model.
Those are the ones with the model. Okay.
Yeah. This is nice. This is nice. Like the modeling. Like I'd probably use this. I might actually legitimately use this at work. Like I might just start using it and then handing over the single line to somebody else because this cleans it up nice, and then I'll say, okay, now draw it off this because it's better than I sketch.
It's only get easier. This is what I got last night, so I like it. I'm glad you're happy. Get these 3D guys in here.
And then yeah, interesting. Cool.
Okay. So we got negative signal positive. Sorry, could you repeat?
Yeah. So the red is positive. So red is positive. So that's coming from the Raspberry Pi. But you already have the connection from Raspberry Pi. Yep. No rush.
Eventually, I'm gonna make this like a Dragon Ball thing. But for now, good. Are you seeing it on your screen?
Yep. Yep. I'm not doing the same. Actually, you're just off by a bit. That's why I'm at a different angle, so I can see how you're off.
Oh, I could not see how I'm off. Okay, cool. That's better.
So yeah, so this would be the basis of the control system for the claw itself, and the brain of the entire arm will be the Raspberry Pi, the battery, the voltage regulator, and the switch. That's sort of the control center. The servo is going to be up the arm, and we're going to have to find a way to wire up the arm and make it such that the wires don't tangle themselves. We'll probably have to limit the arm to have a stopper at 360 degrees, just so that the wires don't over twist themselves and snap themselves. Same thing wind turbines do, actually. Wind turbines, they'll rotate, maybe it's 5 rotations, something like that, before they'll actually unwind, they'll pause and they'll unwind themselves.
That's neat.
Yeah, because their cables get...
Unwind themselves.
Yeah, like imagine your turbine's here and the wind shifts, so it's like, okay, but then the wind shifts over here and it's like, okay, and then it shifts over here and it's like, okay.
All right, well.
And then after 5 turns, it's like, okay, my cables are gonna snap now.
So they'll actually just completely unwind themselves and start over.
Exactly.
Nice.
It's rare. It doesn't happen very often, but
because eventually, imagine over a long period of time, it would get windy, but only if it's consistently in that direction.
That's right. Or if it's consistently turning. And now you have to understand that a lot of wind farms are also in places like beside the ocean where wind is most consistently coming from one direction. It's not like it's a turbulent area that we put wind turbines. It's usually a consistent airflow. Once you finish that up, maybe we should call it. We've been going at it for 3 hours.
Yeah.
It's pretty good.
How do you like this though?
It's great.
The 2D.
It's phenomenal. Yeah. I actually really like that.
Sweet. I think it's gonna take me a little bit to get these lined up well.
Okay.
It's just a little slow. Like it works, but it's just slow.
Yeah, no worries. You don't have to get it lined up if you don't want to.
I do, but I don't know why it's taking so long. It's hard to get the right angle because I'll do it and it turns out it just wasn't the right angle and it's all manual tweaking and.
Yeah, I think we go back to I think maybe we don't worry about this too much and we put a little bit more focus on. Remember the idea we talked about where you can click a point and say that this point associates with this point?
Yeah.
Because
I think so.
And then that way you don't even have to worry about this.
That's interesting. I didn't think about how I could do that. Yeah, I can think about. Okay, yeah, that makes good sense to me.
Okay.
Now that I have this in place, maybe I'm close to be able to actually achieve that. That's interesting.
Because it'd be like, okay, positive, and then click here, and that's my positive.
Yeah, I like that.
No, you're not wasting. Because this points proven here. Points proven.
Probably this is too challenging. Get there.
Yeah.
Do you want to color those while you're at it?
Color the wires?
Yeah.
Sure. We can do that. So let's go here. Let's go Raspberry Pi to servo. We'll also have to.
Walk around. What do you mean?
We'll also have to have this exported name.
Yeah, that's just to make it unique right now. I will clean it up.
All it need. I don't. The uniqueness is fine. It needs to include, as long as part of the uniqueness is the name of that port.
It should have it actually.
It doesn't seem to. Like, for example, Raspberry Pi P6, that's correct, but wire servo, so the one I just made. So it seems like your pre-made ones, correct. But the new one's not correct.
Could you open up body A and B and see what it shows there? Oh, that's interesting. Oh, that's interesting. Yeah, can you open for that one as well? The body A and B there.
This one?
Yeah, and okay, that makes good sense. And then next one, and next one. Interesting. Okay, I got some ideas. Do you mind taking a screenshot of that and send me a note? Okay. That's looking good. Getting take a little bit. Get these wires lined up.
Don't worry too much about them, but
Yeah. I think I was gonna stop here and work on that thing. That will be my goal is how do I make that take a fraction of a second?
yeah.
And that's anything slower is too slow.
Yeah. I think so, because then the 3D model is useful. Right now, it's still not useful because
Because it takes too long to the ports.
Yeah.
Okay. Yeah, I think I have some ideas how I can do that. Cool.
here I'm gonna go into my other browser just so that it's not on the stream. I will go there. Go to good old go.
Uh, um, you're doing that. I'm sorry.
I should add this as an issue, right?
Yes, please. Thank you.
Title. We'll call it. Add it.
Check the block size.
New model.
End of blocks. These are too big. Yeah.
Close that. Close that. Okay. So I think that was pretty effective. What we'll have to do, I will have to make. I think the harder problems aren't the electrical problems. The harder problems are the physical construction
mechanical stuff,
problems. Yeah. So we have developed what I'd consider the basic, the framework to design. I'll actually just add a second servo because we're going to be having two. At least we're going to have two servos, probably a couple steppers. Not really sure, but the claw is definitely going to be two servos at least.
Yeah.
So I'll add a second. Add an object. How do I add a new object from here?
You want just like a 3D model or just anything?
I want another 3D model of a servo.
Oh, you can duplicate the old one if you click on the servo.
Duplicate.
Yeah, click on it and go duplicate.
Sure, but okay. So what if I wanted something different?
Then, well, I guess what did you want? You can just make a box.
No, but one that's existing. Let's say I wanted to add an existing object right
Go.
now.
So uncheck. So just click anywhere. And now
Okay.
you're right. Yeah.
Okay.
I mean, because there's too many things, so I made it like if you select something, you're interacting with it. If you don't have it, yeah.
Gotcha.
I might get rid of that, but for now, UI is already loaded enough.
Yeah, that makes sense. Okay, so now once the I think that once a model's added to the project too, it should stay in your library because like I have to upload the custom model again for the servo.
No, just clone or duplicate it.
Understood.
But yes, I will. But I have no. Like, that's a whole other thing I gotta build.
Okay.
So give me another year. Okay. But yes, yeah, that's the goal.
Okay. Let's click here. Okay, and then clone, duplicate. Nice. Okay. Go here. Servo copy. That's the name. Servo 2. B positive is going to go to 5-volt power 4. We'll end up having to add a bus to this because as it stands, we're already running out of power cords.
Go.
Signal. But for now, it's okay. Signal goes to PWM1. I love that we took the time to write out all the ports for the Pi. So much easier than have to look up its pinout.
Isn't it?
Yeah.
Not pin anymore. And in the future, I want to have it importable, so you can just like search up Pi or search up a new thing, and it'll just like import the pinouts. I found a Snap EDA should be able to do that.
Oh, jeez. Unreal.
Yeah.
Pi's the worst one. Pi's probably the most ports you're ever going to get.
Yeah.
But nonetheless.
But to make it, I like, yeah, better than doing it is automatic. That's what I will.
Yeah, look at our diagram so far. It's good in there.
I like it.
Yeah. Cool.
Yeah, and notice like, so just for anyone watching it, notice how it like auto lays it out, so it understood the symmetry between servo 1 and 2, and kind of lays these things out appropriately, trying to utilize space efficiently. So that means we could just focus on the schematic. We understand, this connects to that. We don't have to think, oh, it has to move over there, and everything should move around.
I'm actually going to disconnect these for now. I'm going to add a bus right now.
Cool. There should be a bus component.
Servo, where's the other servo? Negative. Signal. Add a bus. add another bus.
Another.
Okay, so these are both going to be 5-volt buses. So I'm going to take. So what's happening here from an electrical perspective is we're basically trying to make one power component become multiple power components. Oh, I guess I don't need both because we have it drawn as right. My bad. Delete that. That?
Yeah, add some screenshot to my project. I'm trying to figure out like which project is which. I got too many projects already open.
All right, so now we're gonna add. So we're gonna connect positive to plus. Gonna connect ground to ground. Now we have the ability to make 1 positive, 3 positives, which is what we need because we don't need any control for the power input to the servo. We just need direct 5 volts. So let's do direct 5 volts. And same with the negative. We'll just put the negative to direct 0 volts, direct negative association. Servo positive.
Did you?
Servo
Wait, did you get rid of one of the buses?
Yes. Okay. We only need 1. I forgot the buses are drawn as we have it as like
Multiple.
yeah, it's both positive and negative because that's what we did in real life. We only had 1 bus.
Yeah.
But that was just because we didn't want to buy 2.
Yeah.
Yeah, so a bus is basically just a metal plate that makes connections, and we make multiple connections to it.
That's this piece right here.
Yes.
I'm looking at 3D.
It's a terminal block in that case. Okay, so our 3D model is a little messy, and I don't really want to manipulate it too much just because the wires don't line up properly, but like Glavin and I were saying, I think the next goal is to make that simpler.
Yeah,
Maybe
make the wiring of them simpler.
Yeah.
So yeah, how do you feel with the 2D?
2D is
ports?
beautiful. Perfect.
And the adding and editing of ports experience?
Beautiful. Incredible. Yeah, it's phenomenal.
All right.
It's almost for all intents and purposes in my mind that's done.
Perfect. All right, good. Then I can focus on this stuff. All right. Yeah, so we got that going. I'll think more with the part library pieces, and then what else we got here?
Part library pieces.
Like if you have a servo, then you can keep adding more servos easily, or
Yeah, it's just kind of from the intuitive perspective. I was trying to come back to here to add a new one, and I know you're sitting there saying like duplicate it. And I'm like, yeah, but what if that's not where my head goes?
right. Yeah. I definitely.
Yeah.
I definitely get it. Yeah, I gotta think more about it. It's a complicated thing. So it's like, at what level does it get? So I was thinking we actually publish, like you make the custom things. Okay, it's one off.
Yeah.
Or this is something that's substantial, like publish it, like let's reuse it, or
Like, what if we're in a situation where someday we're actually designing using the software, which I might do, using the software to design something like a power line.
Yeah.
And 60 polls ago, there was an object that I want. Do I want to go find it, click duplicate?
oh, I see. And you want it in cross projects though.
No. Yes and no. I do want that. That's a different conversation. No, but like, let's say we have one big project, and this model gets huge.
Yeah.
And then I'm like, oh, okay, I want that one very specific
I
thing.
want to go over there and get it.
Yeah.
Like, just give me the thing. Like, here, give me the list of what's here. Okay. Yeah.
Yeah.
That makes good sense to me.
It's the argument. It's not for this. It's more for when it gets complicated.
Because effectively, you could do the same as a duplicate. It's just like duplicate in front of me, that looking thing. Okay.
Exactly.
I
Yeah.
got you.
Yeah. Once it's out of the library, you should be able to make it again without having to find it.
I got you.
Cool. All right, but I think that's a good spot for us to leave. We'll probably take I don't know 10 minutes and sort of have a little bit of a debrief outside of stream and just, or actually we could even do it right now. Let's just go into GitHub and write down some notes.
Well, I don't know if I want to show people GitHub.
Right. Okay. In that note, peace out.
Cool. Bye everyone.
Thanks
for
everyone.
watching.
Bye.